Hello, welcome to India's most comprehensive e-learning platform BYJU'S Exam Prep, and also special welcome to every one of you for this wonderful and great Formula 1 series. So far we have done several series, isn't it? We started with the Monsoon series, after that we have done with the Champion series, and we have seen some MSQ Express, MSQ series, so many things we have done. And many of the students commonly they are asking a question, sir, please try to make a concise lecture on control system so that they will get all formulas and all results and all conclusions at a single place so that they can prepare very well for their mock test and followed by the final mock test and even followed by the final gate examination. So as a part of the demand from the students, we came up with a new series that is nothing but Formula 1 series, as you all can see here. And even in the previous lecture, in fact a previous session, many of the faculty came together and explained the wonders of the Formula 1 series. So I am going to start with the control system for ECE and electrical and instrumentation students. However, this series will continue for many of the important subjects in their respective branches. We will try to cover the maximum as well as the most important concepts of the entire subject. In fact, we will try to cover each corner, but only important things. Clear? So we will try to remove the major junk portion from the subject, but majorly we will cover whatever is required for the examination point of view, and these things must be there in your notebook also. In fact, short notebooks you have to prepare by yourself, which must be utilized at the end of the preparation. Correct? Obviously before going to the mock test as well as before going to the final mock test. Well, there are so many students here. Good evening Ashok. Good evening Ravi Shankar. Good evening Pankaj. Good evening Anita. I hope you might understood what is the intent behind the Formula 1 series, right? So whenever I meet any topper in my past experience, there are so many toppers who doesn't have any habit of writing the notes, but everyone has a habit of writing the short notes, including me also. The reason for the short notes is the total subject will be very concise and it will be there on your fingertips. It should be as short enough as. Correct? So guys, are you ready with this? Somebody is asking some question. Will all subjects are covered in Formula 1 series, right? Or scheduled 5 subjects only? No. Initially the schedule is given only for 5 subjects. After that we will going to cover one by one all subjects. Okay, so you can even take this as an assurance. Again I am saying that the more demand comes from the students, naturally we are here to help all of you guys. Clear? So now every one of you must tell me, are you ready for this series? Shall we start control system? Because it may take a little bit lengthy session, almost 2 hours of session. You all must be with me. At the same time, we have to flow the energy between both of us. Then only it is possible to complete the whole subject in 2 hours, such that I can cover the maximum number of concepts. Good evening Monica Gowda and Soumikta. Sir, how long this session? For today it will go. Yes, okay, it will go minimum 2 hours, but don't worry about that. You will really enjoy the section because in a single shot you will be able to cover everything, right? So it will be very interesting to you. Clear? So again I am saying, whatever the important result is there, whatever is important as per the examination point, we will mainly discuss those things. Clear? So some very happy and excited for your class. Oh, thank you very much Monica. Fine. So before going to the session, let me quickly introduce about myself to the new students. As you all can see, myself Phanindra, and all put together I have an experience of 12 plus years, especially training ECE students as well as GATE aspirants. Up to now, I have guided more than 50,000 students in the subjects of control system, industrial instrumentation, measurement and circuit theory. So as I promised you, we are going to discuss about the control system, mostly the formula and the important results and important steps and procedures if you find any. Clear? So these are the chapters which we are going to cover. All the way the topics are also mentioned here, but I want you to focus on the chapters, right? So starting from the basics, where we are going to see, transfer function, impulse response, BDR, that means block diagram reduction as well as signal flow graph. Of course, we will going to see the stability, time response analysis, root locus and frequency response, whatnot. Everything that is there in the control system we are going to discuss. I am not going to leave any particular topic. Clear? So as I was promising earlier, as you all know that the control system is a special subject, it will be having a minimum of 8 marks to maximum of 10 marks, right? So it is one of the most valuable subject in the entire gate preparation, if you are a serious aspirant, surely you will not going to miss any of the session. Correct or not? Right? Some students are asking some interest. I like your explanation in circuit theory, sir. Thank you very much. Very much. Please share your Telegram link at the end of the class. Definitely. Today I am going to share the link. Even if you want the link or the Telegram channel link, you can even watch my previous lecture also. Right? So let's start. It's almost around 5 minutes. So let me start the session. So basics of control system. As I was saying, whenever you are studying the control system, the very first thing that should come into your mind is control system is such a kind of subject. At the end, all the topics can be interlinked. That means what is the purpose? Whatever the purpose the Routh-Harwich criteria is used, the same purpose more or less will be used by gain margin and phase margin. Ultimately, we need to see whether we are able to design the proper control system or not. For that, first you need to start from the basics of control system. Correct? So what is control system? Of course, I don't want to put so many definitions here. More or less, as I was saying, we are going to miss our actual intent if we are going with too much of explanation. Okay, so let me pre-assume that all the students whoever are watching this video, they already have the brief understanding about control system. Clear? So this is the closed loop control system. As you all can see, whenever I say closed loop control system, you must understand there will be some set of input will be given here, which is called as a set point, and this is considered as a controlled variable. Correct? Set point and controlled variable. Now my question to every one of you is, what is G of S? Technically it is considered as G of S, but this G of S is actually the integration of controller, actuator and process to be controlled. But instead of mentioning all these three, in classical control system, we will combine all these three and simply put it like a G of S. Because we are engineers, we want to actually make as simple as possible. Correct? So G of S is considered as a forward path gain and H of S is considered as a feedback gain or the gain of the transducer or the gain of the measurement system. Clear? So Mas Angel, yes, good evening, very good evening to everyone. Lot of response is there. I want you to be there with me till the end of the session. So many new things you are going to learn today if you are with me till the end. Okay. So the very first thing what we require to understand is we are going to give our requirement or the target here, and people do call this as a set point. Clear? This is considered as a set point, right? And this is considered, of course, as a output of the control system. Ultimate purpose of the control system is the response, that is C of t, must be as early as equal to R of t. Clear? So that means at least this value should be as fast as it should be equal to R of t. That means the output of the control system should be equal to the desired target. In a simple word, what I can say is, suppose let us assume that I am having the air conditioner here. So if I switch 25 degrees centigrade, the 25 degrees centigrade given to the air conditioner is called as a set point. And the room temperature is considered as a output of the control system. Ideally, what should happen? If I give a set point of 25 degrees centigrade by using the remote, the room temperature should be finally equal to 25 degrees centigrade. Then I can consider this particular AC or air conditioner as a control system. Clear? To understand whether the output is really reaching to the set point or not, how fast it is reaching to the set point, we must have the transfer function of the closed loop control system. Clear? So Vanilla Pal, good evening. Siva, good evening. Very good. How are you? I am really fine. Hope you are also fine. Right. So the closed loop transfer function is usually given as C of S by R of S is equal to G of S by 1 plus J of S into H of S. Again, I am saying that whenever I write G of S, if I don't mention anything, it means that it has a controller, it has an actuator, it has a process. Clear? So out of this thing, as I said, it is a ratio of the output of the overall control system to the input of the overall control system, correct, in S domain. Therefore, it is called as a transfer function. As we see, the input R of S is the input to the overall closed loop system, C of S is the output of the overall closed loop system. Therefore, C of S by R of S is called as a transfer function of the entire closed loop control system. Correct? Now, most important thing here is the denominator of this particular function, or as the denominator of this closed loop transfer function, it is called as a characteristic equation. Why it is called as a characteristic equation? Any one of you? 45 students are there. Love you guys, and I'm very glad to have great response from all of you. Trust me, I will make this session wonderful and you will remember me the entire life. Okay, so please answer to me and participate in the session. Why we call the denominator as a characteristic equation? Because the denominator will going to decide the characteristics like stability of the overall control system, and also it will going to decide the time constant, time response, many characteristics will be in fact it depends on the denominator. That's why we call this as a characteristic equation. Clear? Now the most important thing is the g of s into h of s, this particular function. So let me take another color so that you will going to understand it in the better way. This g of s into h of s, some people call this as simply like loop gain. Please, some people call this as a loop gain. Of course, some people call this as a open loop transfer function of the closed loop system. Even I have seen many of the gate questions. So many times they will simply mention that open loop transfer function of the closed loop system. And many students, they will simply take this as a g of s. No. If they say open loop control system, open loop transfer function of the closed loop control system, you must take that as g of s into h of s. Clear? Very good, very good, very good. Nice answers, right? Because poles will be decided by the characteristics of the system. Excellent. More or less you have given the formal definition, but the truth is the characteristics of the system will be decided by the denominator. That's why we call that as a characteristic equation. Clear? Moving ahead, the very first chapter, which is very simple. However, it will be asked most of the times for 1 mark, and if you are lucky enough, there is a chance to get even 2 marks. So let me complete this topic very quickly because there are very important topics that will be coming soon. So let's try to give less importance for this because as it is very easy topic, right? So the block diagram reduction, as you know that there are several rules in block diagram reduction, correct? Whenever I say this topic, many of the students, they say that 8 to 10 rules are there. You take the point here, subtract here, add here, something like that. But trust me, if you are good at basic mathematics, you require only 3 important things in this. The very first thing is, of course, this is if 2 blocks are cascaded like this, then the result will be what? Any one of you? So please mention. This is very simple, I know, but you should participate in the session so that the session will be very interactive and more interesting, correct? So if 2 blocks are cascaded, what will be the resultant block? What will be the resultant block? The resultant block will be the product of these 2 blocks, correct? So G1 is the gain of the first block and G2 is the gain of the second block, and the resultant will be equal to G1 into G2, correct? So simple. At the same time, if 2 blocks are connected in parallel, so you can see here G1 and G2 both are connected in parallel. If both of these 2 things are connected in parallel, the resultant will be equal to G1 plus G2, correct? And most important thing, suppose let us say we have G here and there is a point which is connected here. So we call this as some kind of terminal here. Well, let us assume that this is a terminal. Suppose assume that we have R here, clear? R here, and we are very sure that here we will going to get G into R, correct? So R will become G into R. Now if you take this terminal here, so let us consider this as Y, for example, or Y1, and I am very sure that in this case Y1 equal to R. Why? Because it is connected straight away to R. So that means whatever the modification you do for this, you have to get again same value, that is R, at the end of this terminal. Now how we can do? Simple. Suppose if you say it is still again R here, so then obviously this is going to become G into R. If it is G into R, then this will become G into R here, and G into R is multiplied by 1 by G. Then obviously you will be having R here, and once again I can say the output terminal here will be again it is equal to R. Clear? So that means if you take this point after the block, you must keep 1 by G here. Now reverse is also possible. If you want to take this point after the block to before the block, then what we need to do? We need to multiply that with the G. That means 1 by G will be multiplied with the G, then obviously it will be having 1 like this. Clear? So these are the 3 things. Yes, somebody is asking some question, right? Sindhu is asking some question. Sir, is this class enough to score control system? Yes, obviously, because if you are sincere and if you are with me till the end, then only you can score. Okay. However, there are some topics which you require to know the concepts. I suggest that download the BYJU'S Exam Prep and go through the recorded lectures where you can find my lectures. Some topics wherever you are not feeling comfortable, you can go through that. And I can tell you from these all concepts and formula, at least you can get straight away 4 to 5 marks. Straight away 4 to 5 marks. Trust me if you are there with me till the end. Clear? Sir, what is the name of reduction? Which name? Third one. So third one, people do say that takeoff point is moved after the block, right? So that's why I'm saying that don't worry about the name of that. You see the logic behind that. Logic is important more than the name, right? So these are the 3 important things which are required in block diagram reduction. After that, we will be having several things like, y1 will be given here, and suppose let us say plus here added here, and then another y2 will be given here. So then what is the value here? So obviously this is going to be y1 minus y2. Likewise, there are n number of things are there. But out of all those things, these are the 3 main important things which are required to solve any question. If you have any doubt to solve the question, please refer my previous lectures or else the lectures available in BYJU'S Exam Prep. I'm very sure you will be able to answer any question of the block diagram reduction. Clear? Moving ahead to the next one, why negative feedback is more stable than the positive feedback in control system? Very good, Hrithik. So I will ask a simple question. Just assume that you are, maybe you and your brother is staying in the home, okay? And you and your brother both have fighted, okay? So when you both are fighting, your father is the controller in your home, correct? So what your father has to do? Whether he has to amplify the error or he has to reduce that conflict. He has to reduce the conflict. What happens in the negative feedback is, as the controller is understanding the error every time, it will act in such a way that, so the gap reduces between the actual target value and the present value. Clear? But in case of positive feedback, the error gets amplified. The error gets amplified, amplified. Suppose assume that your father is too aggressive. Already you and your brother are fighting. What will going to happen? Your father will come and shout like anything and he will slap you as well as your brother. Then what will happen? It is the amplification of the error, correct? So then the system will become unstable, correct? One fine day you will say that goodbye father, correct? Right? So that is exactly the things. Clear? So, right. So now you can even see the second thing like a signal flow graph, which is more important even in the control system subject, and sometimes it may be important even from the perspective of the circuit theory also, correct? So there are few terms which you must understand one by one. I will go through that. After that, I will give the important formula related to the signal flow graph, right? Nice explanation. Thank you very much. Thank you very much, right? So you all can see the first thing is input node. What do you mean by input node? Input node means it is a junction. It is a point from which all the branches are going away. All the branches are going away. Now you see in this entire signal flow graph, in this entire example, can you tell me what is the input node here? Every one of you must answer here. Everybody in my class, you should be active enough. Then only I will move forward. Okay, everybody must be active, right? In this, please tell me which is going to be considered as an input node. So obviously the node from where the signal is going away, right? All the signals must go away. Clear? So therefore, we call the input node here in this context U as the input node. Good, very good, very good. You. Thank you very much. Right? Now the output node. What is the output node? Usually output node is the node to which all the branches are converging. All the branches are converging. Correct? So suppose let us say this is a point you can see. Finally, it is converged to the Y point here. Correct? So if you look at this whole diagram, this is the terminal or this is a node where all branches are coming, right? Finally, ending at that branch. So therefore, this is considered as an output node, and we can say Y here. There was one question which I have seen in the PSU examinations, I guess, right? Is there any possibility that a branch can leave from the output node? Tell me, can the branch leaves from the output node or not? Yes or no? Yes, every one of you. Can the branch leaves from the output node or not? Yes, it can leave from the output node, and even in this example you are able to see, right? So why no? Because the feedback mechanism itself, it says that output is taken from the output is taken from the end and it is given at the input side. That is called feedback, right? So from the output node, always there is a chance that you can take the data. Clear? So you must be very careful. That's why I see some students are saying no, right? That's why I asked this question, correct? So now moving ahead to the third one, that is node. What do you mean by node? Simple. Node means it is a point of connection between at least two branches should be connected apart from the input node. Clear? Apart from the input node and sometimes even the output node also. Now you can see what are the nodes here. So U is node, E is node, and even Y is also node. We are having only 3 nodes here, correct? And moving ahead, the next one is the branch, right? Branch is basically, it is nothing but a path, right? So in fact, branch is maybe one single line in the path, right? So you can see here EY is considered as a branch here, UV is also considered as a branch, and EY is also considered as a branch. But what do you mean by path, right? So path, you can say like it has to have starting point and ending point in a more defined way, and more importantly, see, from U to E and E to Y and Y to E, I can call this as a path, correct? U to E, E to Y and Y to E, I can call this as a path because I am able to travel along that, correct? So that is actually called as a path, right? However, if you take forward path means start from the input node. This is considered as the input node. We all have called this as the input node here. Of course, we called the Y as an output node here, correct? So this is considered as an output node. Very good. So input node and output node, both of these two things are known to you, right? So now the forward path means start from the input node and all the way travel to the output node. So what is the path available to you? That is U, E and then Y. So that means I can say the forward path here is U and E and Y here. Clear? U, E, Y. Very good, very good. Everybody is very actively participating. Keep like this till the end. Okay, same momentum. And because we have a lot of concepts to cover, Routh-Harwich criteria, root locus, gain margin, phase margin, polar plot, Nyquist plot, so many things are there, right? So be accurate and be on the toes. Now loop. Loop means what? Start at any particular point, and you should be able to reach the same point once again, correct? So that means if we start at E here, yes, from E I can go all the way to Y and then B and again E, correct? So that means I can say E to Y and then again Y. So therefore what should I say here? E, of course E, and then Y and then B here, because B is also considered as a node here, right? And then E here, correct? So of course B doesn't have any significance, but as it is mentioned, I am taking this thing, right? So E to Y, Y to B and B to E. We can call that as a loop if the starting node and ending node can be connected, correct? That means starting node must be equal to the ending node. Now you see here when I write like E, again E is coming at the end. So therefore this is considered, this path is considered as a loop now. This path is considered as a loop. Now can you tell me what is the gain of this loop now? If I ask what is the gain of the loop, how can I say from E to G we are having G and then H and then -1. So when you are traveling all along the path here, whatever the gains you are having on the branches, you can multiply all those things to get the complete path gain, correct? So what is the complete path gain here? Minus G times of H. Simple. Minus GH is going to be considered as a path gain, correct? Now what do you mean by non-touching loop? This is also very important to understand. Suppose let us say we are having here one more node here. Assume that for example Y1, and maybe you are having like Y2 here, and this is connected like this. Clear? This is connected like this. So now if it is connected in this way, loop 1 is this one and loop 2 is this, correct? So how do we define the non-touching loops here? Whenever I am writing loop 1 here, it should come like E, capital E, Y and B of course and E, correct? This is so simple to understand. Now look at the loop 2. Loop 2 we can say it started from Y1, right? And again Y2 and again it is coming back to Y1, correct? So it started from Y1 and gone to Y2 and again coming back to the Y1. Now how can you say whether the loop 1 and loop 2 are touching or not? In a simple way, because don't say that sir I can see the diagram, I am Lord Brahma, so by just looking at the diagram I can say that, right? So don't play with the technical topics, right? So the most important thing is when you write like this, look at is there any nodes are matching here or not, correct? So now if you see, the nodes here are E, Y, B and E, but here Y1, Y2, Y3, correct? So obviously these two loops are not matching because none of the node is common, same node is touching. Where no, it is not same node is touching. We started at E and we are again coming back to E. Then only it is called as a loop. Intermediate nodes should not touch more than once. That means Y should not come more than one and B should not come more than once. Clear? Starting node should come more than once, then only at 2 times. Then only you are covering the loop, isn't it? So be accurate in this, right? So I hope you understood that this is non-touching because there is no node which is common to loop 1 and loop 2. In case if I take some other loop like this, assume that if I take some other loop like this, right? So the third loop I can say now, that is started from Y1 and Y and then again Y1, correct? So this is the way how it is traveling, correct? So this is the way how it is traveling. Then what can I say? Loop 1 and loop 3 are touching and loop 2 and loop 3 are also touching. But loop 1 and loop 2 are non-touching loops. Clear? So I hope you understood this, and I too agree that many students knows this. Now let me directly go to, already I told you path gain. Path gain means whatever the gain that you are getting throughout the path here, correct? Just simply I am asking a question. If I take this is 2 and this is 3, what is the loop gain of L2? Every one of you fatafat answer this one, right? Y and Y dash are touching here. Yes, where is Y dash? I don't show you anywhere Y dash, right? Sindhu, where is Y dash? Sir, can I crack gate 2026 with AR 50? Definitely everybody can crack, right? So yes, 2 into 3, that is nothing but the 6 here. That would be considered as a path gain. Clear? Path gain of what? Path gain of loop 2 here. Clear? Path gain of the loop 2 here. I hope you understood the whole logic here. So in short, I have explained each and every topic here. Moving ahead, so the overall transfer function or the overall gain can be given by a special formula that is nothing but Monsoon formula, especially in the signal flow graph, which could be written as the transfer function is equal to k equals to 1 to n pk delta k by k delta. Suppose k defines the number of the forward path. Suppose let us say, in fact, k is nothing but, look at that, or else n. In fact, we can say n here, that would be more appropriate. N would be considered as, let me write down, n is considered as number of forward paths. Clear? So suppose if I say n equals to 2, what does it mean? There is a chance that 2 different paths are available to travel from the input node to output node. Clear? So therefore, suppose for example, if I take n is equal to 2, how this formula will be changing now? Now the transfer function could be written as equal to P1 delta 1 plus P2 delta 2 whole divided by delta here. Clear? Because k will become k2 1 to 2. Clear? This is very easy to understand. Now let me explain each and every term here. So pk is considered as a gain of the kth forward path. Suppose if you are taking the first forward path, you must use the gain of the first forward path. If you are taking the second forward path, you must use the gain of the second forward path. Likewise, pk denotes the gain of the kth forward path. And most importantly, n is nothing but the number of forward paths in the graph, as I said. And delta is considered as a determinant of the graph. The most important thing in the entire Monsoon formula is delta. What is delta? Delta is very simple. Look at that. Delta is considered as a determinant of the whole graph. In fact, that can be written as 1 minus sum of individual loop gains. Correct? So can you tell me here what is the individual loop gain if you ask this question? What is the loop gain of L1? What every one of you please tell me. So what is the loop gain of the first one? L1 has a loop gain here. Everyone must answer along with me. G and H and minus. So it would be minus G into H. That is simple. What is the loop gain of the second loop here? Second loop is 2 into 3. You already told that 2 into 3 is the 6 here. So let me say this is 6. What is the third loop gain? Third loop gain, let us assume that you started from here 2 and maybe you take it as a 2. So then you started from here, this is 2 and this is 2. All the way you will be having 4 here. Clear? You are having 4. Therefore, I can say all put together, there are 3 individual loops, we have to take the sum of all individual loop gains, and then sum of gain product of, this is very important, gain product of all combinations of two non-touching loops. This is wrong, 2 non-touching loops. Clear? So that means after finishing this one, go back to your graph and look at what are the non-touching loops pair, 2 non-touching loops, and then multiply the gain of the 2 non-touching loops and take all those things and again add here. Clear? Likewise, you have to continue. Most of the times you will be stopped here, correct? Because in GATE, you will not be getting a very lengthy questions, rather you will be getting a tricky questions. Clear? You will be getting a tricky question. So that is considered as a delta. But what is the value of delta K here? Because you are seeing here, delta might be clear to you. Delta is clear to you. But how do we write delta 1 and delta 2? Very simple. Delta K is actually nothing but the value of the delta. Look at that. The value of the delta for the part of the graph not touching the kth forward path. That means apply the same concept of finding the delta, but look at that, everything should not touch the forward path 1. What does it mean? When you are calculating delta 1, what should I write here now? 1 minus, correct? 1 minus sum of individual loop gains. Let me write down sum of individual loop gains. But this should not touch forward path 1. Clear? This should not touch forward path 1. And then again plus sum of gain products of 2 non-touching loops. Right? So 2 non-touching loops. Again, these also should not touch the forward path 1. Clear? Likewise, the same formula we will going to apply. Sir, your teaching is simple. Thank you very much. Thank you very much, Karan. Right? So this same formula you must apply, but you must think that everywhere this should be applied by not touching the forward path 1. Similarly, if you go for delta 2, then you must know that it should not touch the forward path 2, but rest of the delta formula will be same. Now I have a question to every one of you. Most of the times, which kind of questions you have seen? 2 forward paths or 3 forward paths? If you already solved the GATE previous year questions, you will understand that all GATE previous year questions which are there on the signal flow graph, they are not at all difficult. Most of the times you will be maximum having only 2 forward path gains. More than 2 they won't go. And even sometimes they don't even go for 2 also. You will be having only 1 forward path. Clear? Right? That's why this is sufficient to know here. I hope I have covered the very first topic, that is signal flow graph as well as block diagram reduction. Of course, I have taken some time, but as you all know that initially I may be taking some time, but once I pick up, then everything will go very fast. Okay? Right, right, very good, right. Thank you very much. So first chapter is completed. So everybody, I need the response from you. Is it clear to all of you, or I am going little bit fast, or you expect me to go little bit fast? Right? So every one of you, so many students are there, 60 students, everybody must answer to me. The second chapter, what we are going to discuss is the time response analysis. So what do you mean by time response analysis? It's very simple. We will have a system, specifically that is a control system. We may apply different inputs and we will see how the response is varying with respect to time. Simple. Therefore, it is called as a time response. Simple, right? So please take this kind of revision session in sensors also. Sure, Pramit, I will take it. Don't worry, right? I have to take it. Okay. So the time response analysis, as I was saying, you will be having at least, again, this is also minimum 1 mark to 2 marks weightage will be given. But what I should say is, time response analysis, seriously speaking, this is not only limited to control system. Okay. It is not limited to control system. It is a general topic. In control system, we will see the time response of control system. Suppose if you have amplifier, in analog electronics, you will be seeing this one. We will be having amplifier, correct? And for amplifier, we will be applying the DC input and we will see what is the response here, correct? So that is considered as a DC response, isn't it? After that, we will apply AC signal, AC input. Again, we will see what is the response here, correct or not? So what does it mean? Everywhere you are going to use the time response. That means understanding the response with respect to time is called as a time response. This topic is not limited to only control system. It is there for circuit theory. It is there in analog electronics. Therefore, you must be with me till the end of this session. Okay? Right. So moving ahead, the very first thing what is important to know in time response is different kind of signals. Correct? So Hrithik is asking something, right? Once explain delta 1 and delta 2, sir. Sindhu, I think Sindhu, you are learning this first time. Anyway, I will explain. Don't worry about that. Right? In a problem of signal flow graph, to find a transfer function, do we need to consider the loop gain at input node? Excellent question. Excellent question, Hrithik. So my suggestion, I will make you to answer this question. The best example is, instead of using the letters, you use the numbers, right? At the input you started and again you came back to that, right? So what do you mean by input node basically, right? So input node means all the branches should go away from that, correct? All the branches should go away from that. Suppose if you have R here, and let us call this as a Y1 and let me call this as a Y2 here, and if I say in this way, correct? So when you can call this as the input node, you can call this as the input node if all branches are coming out of the node, correct or not? But if there is a loop here, then how can you call that as the input node? You cannot take that as the input node, right? So that's why usually when you are having the loop at the input side, we will not take that into the consideration. Clear? We will not take into the consideration. Hope you understood that, right? So I hope every one of you understood this one. Now let's move on to the next one, that is, right, different types of input signals. As you know, the very first test input signal which we apply is the impulse, and we write the strength of the impulse. Strength of the impulse, we don't call this as the magnitude of the impulse, right? We call that as a self, it is considered as the area or the strength of the impulse signal. So exactly at t is equal to 0, you will be seeing, or when the time is tends to 0, we will be seeing a sudden spike in the signal with a strength of A. Therefore, we consider that input signal as R of t is equal to A into delta of t. And as you can see, this will have strength A only at t is equal to 0. Other than t is equal to 0, the strength will be considered as 0. Clear? Make a dummy node. Excellent, Satish. Right? So to solve that question, when you are having the same node there, same loop there, we will extend that and make a dummy node at the input side. Clear? That is correct explanation. Right? Now Hrithik Samala, have you understood my explanation? I think Satish understood very well. Pankaj also understood very well. So I want to know whether Samala, Hrithik have understood it or not. Right? So nice. Now the impulse is very clear, but most of the times we require to know what is the Laplace transform of this one. What is the Laplace transform of this one? Fatafat answer. Premit, where are you? R of S is equal to A. R of S is equal to A. Yes, clear, sir. Thank you. Now the second is the step signal. Step signal is nothing but constantly maintained the input. Clear? So that input will be constantly maintained for long amount of time or long duration. That means once t greater than or equal to 0, we will be taking its magnitude as A. However, t less than 0, it is considered as 0. Clear? So that's why you see after t greater than 0. So during this portion, the strength of this signal is A, and t less than 0, you are having the strength of this signal as nothing, right? So that means most of the causal systems, when we apply the input, when we say time t greater than or equal to 0, its input will be A here. And what is the Laplace transform? Obviously the Laplace transform R of S is equal to 1 divided by S. Clear? In fact, if it is A, then it must be considered as A by S. Right? Now likewise, we are having another important signal which is considered as a ramp signal. So which is nothing but R of t is equal to AT into U of t here, right? So in this case, it is a linear function. That means the, signal strength will going to increase with respect to time. So that means starting the value might be 0, but when the time is progressing this side, the output side, the value also will going to progress with the slope of A units. Clear? So that's why it is mentioned as R of t is equal to A into t into U of t. Therefore, R of S could be considered here as A by S square. Clear? A by S square. These things you need to keep all these things in your fingertips. And moving ahead, the next one, that is parabolic signal. So you all can see here, right? R of t, you can see y is equal to m into x square here. This is y equals to m into s square. Correct? So if it is a parabolic signal, of course this is the way how it is non-linear here. But may I know what is going to be R of S here? Any one of you? R of S will be how much here? Any one of you? R of S is going to be how much? Ashok, Samyukta, right? Samyukta, Hrithik, Satish, Pankaj, Pramit, Anita. So can you tell me what is the parabolic input? Parabolic input Laplace transform is how much? So this will be a2 square is there here, right? So 2 factorial will be there, 2 by it is going to be s cube here. Clear? 2 times of a divided by s cube. Clear? So 2 times of a divided by s cube. I hope you understood this one, right? Every one of you, please tell me, is it clear to all of you? Yes, 2 by s cube. A is there, so don't forget that one. Now let me move to the next topic, that is step response of the first order system. Now whenever I say first order system, let me clearly tell you, most of the students, they don't know this thing, right? C of s by r of s, right? That should be equal to ks divided by 1 plus tau s. This is what most of the students, they say to me. But remember, in general first order system means, I can say instead of this, look at that. Today you are going to learn some of the new important points also. So please see here. If I say some general system, y of s by x of s, clear? Some general first order system. General first order system, y of s by x of s, I can say ks by 1 plus tau s. And if it is so, ks is considered as a static gain or steady state gain or DC gain. Clear? Static gain or steady state gain or DC gain. And tau is considered as a time constant. This is known to every one of you, right? So this is the general first order system. But whenever I say first order control system, look at that. First order control system. Clear? There is a difference between first order system and first order control system. If I use the first order control system, then output will be written as C of s and input must be written as R of s here. Clear? This is first order system, but this is first order control system. Clear? First order control system. Now you tell me, if it is first order control system, what must happen here? What is the difference? The difference is here you will be having 1 divided by 1 plus tau s. Clear? So that means ideally the steady state gain equal to 1. Ideally the steady state gain must be equal to 1. What will happen? If the steady state gain is equal to 1, at steady state the input and output both will be having the same magnitude, then the steady state error will be 0. Clear? I repeat, ideally we expect the steady state gain must be equal to 1. Then only at steady state, the steady state input and steady state output both will be same, therefore the steady state error is equal to 0. So you must know what is the classical difference here. As we are not going to discuss about the system performance here, we are mainly aiming for the control system, correct? So let me take C of s by R of s is equal to 1 by 1 plus tau s, and we are having here C of s and R of s clearly here, right? So now what is most important for us is the step response, because you can apply impulse, you can apply ramp, you can apply many things, but ultimately what is important, that only we require to study here, because right now we are in Formula 1 series, right? So step response. Step response means what? What is the input we are applying here? So R of t must be equal to, let's assume that unit step response here. Clear? Unit step response, let me write down. If I say unit step response, R of t must be equal to 1 into U of t. Correct? Therefore R of s, undoubtedly it will be equal to 1 by s. And you can multiply 1 by s with this 1 by 1 plus tau s and finally get C of s. And if you want C of t, how you will find C of t? You will find Laplace inverse of C of s. But how we will be having C of s here? L inverse of C of s is nothing but R of s value that should be multiplied by the G of s value. Let's assume that this is G of s, for example, or T of s, K of s, anything, no problem, right? So this would be written as 1 by s into 1 divided by 1 plus tau s. And once you take the Laplace transform of this, inverse Laplace transform of this, then you will going to get the step response, correct? So probably you all might be knowing that step response here. So let me directly write down here. Clear? So the step response, obviously this is considered as a step response. Now every one of you must tell me one important factor here. What is the initial value of this response? Any one of you? What is the initial value of this? Initial value. Anita, Satish, and please let me know, Ashok, what is the initial value of this? If I ask initial value, that is very simple to say. Initial value, let me write down, that is IV, which is equal to C of 0. Substitute t is equal to 0. Then it will become like 1 minus e power 0 whole, right? So 1 minus e power 0, that will be 0. Simple. And what about the final value here? Final value means we will substitute t is equal to infinity, correct? When you substitute t is equal to infinity, then you will be finding that 1 minus e power minus infinity all the way this will be again equal to 0, correct? Then if we start plotting the graph for C of t, which is nothing but the step response, this is the way how the graph looks like, correct? Most of you knows this point, right? So the step input, let me say all the way it might be up to here, step input, and the time constant is nothing but the value where your output response, this is C of t, graph is C of t, reaches 63.2% of the final output if the initial value starts from 0, correct? So 63.2% of 1 is how much? It is 0.1632. That's why it is called as a time constant. Clear? Now everyone t is equal to infinity, it should be like 1, sir, right? Oh, I am sorry, extremely sorry. Thank you guys. Thank you very much. Thank you very much, right? So small mistake. 1 minus e power minus infinity, so that would be equal to 0, so it should be equal to 1. Thank you very much, right? Gajendra Singh, thank you very much, right? So now what is going to be the settling time here? So in the first order system, when I apply the step input, settling time means the time required for the output to reach 98% of its final output change. That is, if I say 98% means it should be 0.98, right? 98% of the output step change. Output step change is only 1, maximum change is 1. 98% of 1 means it is 0.98. Tell me what is the formula now, every one of you, right? What is the formula? E power minus infinity is 0. Anita, wrong. E power minus infinity is wrong. Just check it. Okay, e power minus infinity is 0. Right? Yes, Anita. Good. So tell me what is the settling time here? So this time where we are going to reach, where the step response reach to 98% of the final value, that particular time will be called as a settling time, which is nothing but 4 tau. This is one important formula. Clear? This is one important formula. At the same time, rise time, another important formula here, which is nothing but the rise time. Any one of you in first order system, what is the formula for rise time? Now hereafter you must be very active and quickly answer to my question, right? So around 50 students are there in the live. You must be very fast and quick enough to give the answers to me, right? You like me, you love me, so you must participate in the session also, right? So T rise is what? T rise will be equal to 2.2 approximately. I am writing. Don't argue with me, sir. It is 2.222 like that. Don't say that. So it is approximately equal to 2.2 tau. If anybody is very interested to know how this formula is coming and what is the meaning of rise time and how to derive the rise time, you can refer my BYJU'S exam prep lectures. You can refer my lectures, recorded lectures or live lectures. There you can find the definition, derivation, everything. If I started to derive everything, then the purpose of the whole session and the intent behind the session will go off. Clear? So rise time is equal to 2.22 and the settling time, as I was saying, that it is equal to 4 tau here. Right? Clear? Now let's move on to the next one, that is second order system. So when you consider the second order system, the transfer function of the second order system should look like omega n square by s square plus 2 zeta omega n s plus omega n square. Now there are many important factors here. The very first thing is omega n, which is called as a natural frequency of the system. Again the same story. If you want to know what is the definition and why it is called natural frequency, what are the practical examples, physical examples, you must go through the concepts, right? So it is the now zeta. What is zeta here? Zeta is considered here as a damping ratio. Let me write down zeta, which is considered as a damping ratio. Clear? And zeta and omega n, these are the two major, parameters which will decide the beauty of the second order systems. Clear? Sir, PDF. Yes, definitely, Ashok. After the class only you will be getting this. Okay? Right. Right. Gajendra Singh, wonderful question you are asking. Sir, why rise time is 10 to 90% in some cases and 0 to 100% in some cases? Good question. I'll tell you simple way. So whatever the input you apply for whichever the system, we generally expect the quick response. If the response is very quick, then we will going to take 0 to 100% because we know that there is a chance that from 0 it may reach to 100%, right? But if you feel that the response is not so quick enough, then we will aim to take from 10 to 90%. The reason is two reasons are there. Reaching 100% may be taking a lot of time. So we cannot conclude that. That's why we will keep the higher limit as 90%, and 0% it may start very fast. Clear? That's why we will start from the 10%. So everything is our comfort only here in this case, because sometimes the system may start with a huge immediate response, and even it can touch the final value 100% in very less amount of time. If that is the case, you can consider the rise time as 0 to 100%. But if you know that it will take a lot of time to settle at 100%, then we will limit ourselves to 90% because we don't have the patience to wait for 100%. Clear? I hope Gajendra, it's clear to you, right? So Deepika is asking my Telegram channel, simple, that is at the rate of IN Guru. So you can type this in the Telegram channel, Telegram you will be getting, or you will be directed to my Telegram channel. Okay, Guru 22. So Gajendra, you tell me, is it clear to you? Because I have explained clearly, as we cannot wait for 100% in most of the times, we will take it for 90%. Clear? Gajendra, I need the response from you. If you are not clear, I am ready to explain once again. So tell me. Right. So omega n and zeta is known to you. And there is one more important term, that is omega d, which is considered as a damped frequency here. Okay. So let me call this as a damped frequency here. Of course, omega d could be written as equal to omega n into under root of 1 minus zeta square. Clear? So Gajendra, yes, clear, very good, very good. Sir, on which parameters is the natural frequency? Depends. Good. So in electrical system, you might be seeing that oscillator. Oscillator is a simple concept, right? So what is oscillator? Without any input, it will start giving the output. How it will give the sinusoidal output? Because the inductor and capacitor, whatever present there in the oscillator circuit, inductor will start giving the energy to the capacitor, capacitor will give the energy to the inductor in cycle by cycle. That's why we will be getting the sinusoidal signal. Correct? So the frequency of the sinusoidal signals will really depends on the value of inductance and capacitance. Correct? So the natural frequency of the sinusoidal wave, whichever is coming after the oscillator, depends on the inductance and capacitance. Means charging elements. Clear? Charging elements. That means in a very complicated system, look at which are the elements. They cannot react instantaneously. Natural frequency depends on those elements. Clear? Suppose if you take RLC circuit, in RLC circuit, we all know very well that in RLC circuit, inductor and capacitor cannot react very fast. Correct or not? So that's why these two will come in the participation of deciding the frequency of the waveform, because they will be exchanging the energy, right? So that is the principle. I hope you understood that. I think today I have given a wonderful statement, right? So who is this? Harinataraju. Harinataraju, please tell me, have you got the point now? And this is a new point. Thanks for asking this question. I think many of the students got today only that how natural frequency will going to change, right? Yes, yes, very good, Ravi Shankar. Now, omega d is considered as a damped frequency. However, depending upon the zeta value, the second order systems will be, classified like this. Starting from the very first one, if at all zeta is equal to 0, we call that as an undamped system, and zeta, if it is there in between 0 to 1, we call that as an underdamped system. If zeta is equal to 1, critically damped, and zeta greater than 1, it is considered as an overdamped system. Correct? Now moving ahead to the next one, the step response of second order system. That means we will take the second order control system, because we are in the topic of control system. So everything what we speak is about control system only, right? So take the second order system and apply the step input, especially for underdamped system. Underdamped system, what I told you, zeta must be in between 0 to 1, correct? If the zeta value is in between 0 to 1, we call that as the underdamped system. And for that kind of system, if you apply step input, then you will going to get all the way the step response like this. Clear? The step response will be exactly like this. In this step response, most important terms are 1 minus e power minus zeta omega nt under root of 1 minus zeta square sin omega dt. Each and every term you know here. The only point is cos inverse of zeta. Some people are not interested to write, so they will write this as a phi. Clear? So if you start writing this as a phi, how the whole formula will going to change now? Now the whole formula can be written as 1 minus e power minus zeta omega n into t, of course, whole divided by 1 minus zeta square, undoubtedly, right? So into sin omega dt omega dt plus phi. Clear? So this phi could be written as cos inverse of zeta, or this phi can be written as, look at that, this is very, very important. Sometimes you may be asking many questions on this. Sin inverse of under root of 1 minus zeta square, or it can be written as, so this is again one more formula is there. It can also be called as a tan inverse of under root of 1 minus zeta square divided by zeta. Once again I am saying, those students who want the formulas, who want the explanation, who want the concept behind this, you all can refer my lectures in BYJU'S Exam Prep app. Don't ask me how you got these formulas now, because we are in formula series, right? Okay, so now this is considered as a step response of underdamped system, right? So what is most important is, you must understand the step response started from 0 very fast. It started from very fast from 0, and this might be the required value. 1 is considered as a required value, and even this would be considered here as a C of infinity also. Look at that. Substitute t is equal to infinity here. If you substitute t is equal to infinity, can anybody say what is the final value you will be getting here? Look at that. If you substitute t is equal to infinity here, then this factor will become 0. So irrespective of what is there here, as this value is 0 all the way, you will be having simply like C of infinity is equal to 1. Easy, isn't it? This is correct. Nobody can counter this one, correct? C of infinity is equal to 1. That is called as a final value. Now the problem with the underdamped step response is, or the step response of underdamped system is, response starts from the 0. First it will shoot. It will shoot more than final value, and again it will start oscillating like this and finally start settling like this. Clear? This is the step response of underdamped system. Clear? And when it happens like this, most important point here is how much amount of overshoot that occurs here. Of course, this is considered as a maximum or the peak value. This is considered as a peak value, and whatever you are having here, so let me write down. Clear? So whatever we are having here, especially this is considered as a gap between the peak value. This is called as a peak value. Let me write down peak value, and the time at which you are getting the peak value, usually that is called as a peak time. Clear? That is called as a peak time. And most of the times it is a common question that either what is the peak time, or else you will be asked about the percentage of peak overshoot. Now let me ask you one by one each and every question. All of you, yes, maximum peak overshoot. Very good, maximum peak overshoot. Nice, excellent. Very good. Good to see your patience, right? Lot of students, still we are in the second chapter, but same momentum and same energy is there from all of you. Thanks for your love. Let me know first of all what is a very important formula here. Rise time, correct? So let me write down, otherwise, because you people are looking very sincere, so let me write down everything here. So the first point is rise time. So what is the formula for rise time? So the rise time, don't see any notebooks, just listen to me and recall your concepts. Recall means just look at that and get back whether you are able to get in the concept or not. Okay. So the rise time could be written as pi minus phi divided by omega d. Correct? So is it correct or not? Every one of you please let me know, is it correct or not? Phi minus phi by omega d. Now where pi is a simple value, that is 3.14, and this phi is nothing but what? Phi is nothing but cos inverse of zeta. Everyone start recalling the formula one by one. Okay, because we are in race, right? So pi minus phi divided by omega d, where omega d is omega n under root of 1 minus zeta square. Don't keep any notebook with you, just follow me and listen to the class. Okay. The second important formula here is peak time. So the peak time, and here the real game will be there. So please see, peak time means the time taken for the output to reach the peak value. Correct? So that would be usually given as n into pi divided by omega d, and many times there is a question on this topic. Many times, so many times they ask the question on this. So tell me what is the value here. Suppose for n is equal to 1, 3, 5, you will be getting etc. You will be getting first, second, third overshoots here. Clear? So you will be getting first, second, third overshoots. In fact, I can say if the value of n is odd number, you will be getting the overshoots. Clear? You will be getting the overshoots. And at the same time, if n is equal to 2, 4, comma 6, etc. Then look at that. You will be getting first, comma second, comma third undershoots. Hope you people remember the concepts what I have discussed in the regular sessions, right? Undershoot here. Clear? So this is considered as an undershoot. Now suppose if anyone asks you a question, what is the value of n for third undershoot? Tell me what is the value of n for third undershoot. What is the value of n for third undershoot? N is equal to 1 means it is the first peak overshoot. Second means first undershoot. Third means second overshoot. Fourth means second undershoot. And fifth means third overshoot. Sixth means third undershoot. Clear? Third undershoot. So therefore, I can say if anybody is interested to go for the third undershoot, you must have the value of n is equal to 6. Clear? But most of the times they don't ask this kind of stupid questions in the gate. But in PSUs you will be facing this kind of questions. And the next one, what is the next one? Next one is peak value. What is the peak value? How do we find the peak value? Simple. So peak value could be written as a C of TP. Very easy, right? So that means go back here, substitute the peak time in the expression, then you will going to get the peak value. Simple, very easy. Now the next and most important thing, many times, countless number of times they ask this question, that is percentage of peak overshoot. So let me write down percentage of peak overshoot. POS means peak overshoot, which is nothing but we call that as a MP, which is equal to, any one of you, what is the percentage of peak overshoot? Percentage of peak overshoot, it should be written as e power minus zeta into pi under root of 1 minus zeta square whole into 100. Clear? This is considered as a percentage of peak overshoot formula, which is again very, very important. And when it comes to the last but not least, settling time. So now you should be fast enough. Settling time, right? So settling time, there are two formulas. One is 3 by zeta omega n, correct? So 3 by zeta omega n, and TS is equal to 4 by zeta omega n. Tell me what is the difference between both of these two? Any one of you? Any one of you, what is the difference? So 4 by zeta omega n is for 2% of the band, 2% of band in final value. Output must reach within plus or minus 2% of the final value. Clear? Here it is going to be 5% criterion. So that is 5% of band in the final value. Clear? So hope you understood these two things, right? So in many times I have seen the questions will be very straightforward. They will ask that what is the time, settling time taken for the 2% criteria. 2% criteria means you should take 4 by zeta 1. How do we remember this one? Any one of you, can you tell me how we can remember this one? Because it is taking more time to reach 2% compared to 5%. 5% it will reach very fast, correct? 5% means maybe somewhere here, correct? So 5% means 50%, 95%, maybe here, right? So this will reach very fast compared to 2% here, correct? So therefore that's why you all can see and understand here, it takes less time to reach 5% compared to 2%, correct? That's why 5% settling time is less value and 2% settling time will be more value. Clear? So easy to understand. Up to now, everything is clear or not? Every one of you must answer to me in the comment section. Is it clear to all of you? We are coming to the last topic of the time response analysis. I need your motivation also. Please tell me, is it everything is clear or not, right? So moving ahead, steady state error. I will tell you the easiest way to answer any question in steady state error. Don't run behind the formula. In this case, don't run behind the formula. Try to strict yourself to the basics. Don't go like, different formula for non-unity feedback system, different formula for unity feedback system, all these things, right? People made so many complex things. Easy way is, look at where the question is. What is the question? Question is, if they say that this is the error they are looking at, clear? So this is the error. And you require to find out what is the steady state error, correct? So first of all, try to understand like this. What do you mean by error here? Error, suppose in case if I say h of s is equal to 1, clear? if I say h of s is equal to 1, or even h of s is not equal to 1 also, right? So what do you mean by error? Error is actually nothing but the control system output, whatever you are, in fact, it would be written as, listen carefully, error is nothing but, it could be written as simply like E of t, which is actually nothing but the difference between the target and the present value. This is a simple catch, right? You need not to mess up anything. I have given 25 degrees centigrade as a target here, clear? When I give 25 degrees centigrade as a target to the air conditioner temperature might be right now, the room temperature might be 23 degrees centigrade. Then tell me, suppose I have given 25 degrees centigrade as a target to the air conditioner. Clear? I just took the remote and pressed 25 degrees centigrade to the AC, air conditioner. And after 10 minutes is a very big time, right? Or 15 minutes of time, I came back, I have seen that it is showing like 23 degrees centigrade, right? So that means the temperature is showing as 23 degrees centigrade. Tell me what is the error? 2 degrees centigrade is the error. How you are taking? This is your R value and this is your C value. You are simply subtracting these two, correct? You are not looking at the feedback device. You don't look at the feedback device. You will take the difference between 25 and 23. That is considered as the error. Right or wrong? Right or wrong? Every one of you must tell me. Yes, yes, very good, Narsimha. Original minus output if there is a change in the output here. Excellent. Very good. That is a common sense, isn't it? Right? Now every one of you must tell me, is it clear or not? If it is clear, then don't worry about whether the unity feedback is given, non-unity feedback is given, how to convert non-unity to unity, unity to non-unity. This many formulas are not required. The only thing what is required is error E of t is equal to R of t minus C of t. But for God grace, most of the times, 99.9% of the time, you will be given as a unity feedback. So you will be lucky, right? So this is mentioned like this. Now moving ahead, E of t is known to you. Then what is the steady state error means? Steady state error means, let me write down steady state error as SSE, which is equal to error at t is equal to infinity. Clear? Error at t is equal to infinity. So therefore, it could be written as E of infinity, that is equal to R of infinity minus C of infinity. That means wait for some time and see the difference between the desired input and the actual value of the output. So the desired input is R of infinity, actual value of the output is C of infinity. In our case, R of infinity is the 25 degrees centigrade. Means after 20 minutes of time also still the room temperature, required room temperature is 25 degrees centigrade. But C of infinity is 23 degrees centigrade. That's why we have 2 degrees centigrade as an error. Clear? So some people are not very happy with writing this. Rather they will convert this into the Laplace form. If we convert this into the Laplace form, the error E of s could be written as equal to R of s minus C of s here. Correct? R of s minus C of s. And if you want E of infinity by using the final value theorem, how can I write E of infinity? By using the final value theorem, E of infinity can be written as limit s tends to 0, s into E of s. Clear? S into E of s. And as we know here, limit s tends to 0, no problem with this one. However, s will be there. Inside the bracket, what is there? R of s minus C of s. And this is the only formula I can request you to keep in your mind, because most of the students, they remember so many formulas for steady state error, and finally they will come back to my lectures even next year also. Clear? In steady state error, try to remember as less as possible. Okay, go with the basic as much as possible. Clear? So that is steady state error. However, some students will not be happy if I say that just go with the only formula. Sorry, go with the basics. They will be asking the formulas. So let me define something here. Positional error coefficient, which is considered as Kp is equal to limit s tends to 0. G of s into h of s is considered as a Kp, and velocity error coefficient Kv is nothing but, how do you get velocity? Velocity is equal to dx of t by dt. Correct? So that means if you take Laplace transform of velocity, what you will going to get here? S into x of s you will going to get. Correct? If the initial value is 0. That means whatever you are having velocity error coefficient, you should multiply with the s. That's why limit s tends to 0, g of s into h of s is there. Additionally, we have s here for the velocity. Simple way to understand. Correct? And you may ask a question to me, sir, what is this positional error coefficient and velocity error coefficient? As I was saying, if anybody is too much interested to know the concept, please go to the lectures, right? Let's discuss the formula here. So the acceleration error coefficient could be written as limit s tends to 0, s square into g of s into h of s. Clear? So these things are clearly sufficient to answer any question in the steady state error. But there is one table which is there in the steady state error, and most of the students, they regularly ask that question, sir, please discuss about the table. But I know personally that the table is not required to answer any question, but for your satisfaction I have to do it. So let me explain that also, right? So here, for example, if I take step input here, for example, and assume that here I will be taking the ramp input here, ramp input and I have to take the last one is going to be what? Parabolic input. Parabolic input. Now, if I start the left side with the type 0 system, and type 1 system and type 2 system. Clear? What do you mean by type of a system? Any one of you? Pramit and Ashok and all of you, please tell me what do you mean by type of a system? Type of a system is nothing but number of poles lies at the origin is called as the type of a system. Suppose let us say g of s is equal to 1 divided by s square into s plus 1. What is the type of a system? G of s is equal to 1 by s square into s plus 1 into s plus 2 whole square. So what is the type of the first one and second system? Type of the first one and second system. Clear? Type of the first system and second system. Every one of you must answer to this. So type of the first system is how much? Type of the first system is number of poles at the origin, that is 2. And even in the second case, number of poles at the origin is 2. So therefore it is going to be 2. Clear? So what do you mean by, why we are so interested only about the type? Why not the order? Have you ever investigated this? It will be so interesting, right? Why we are interested only in this? Why not the order? Reason is mathematically you may say that yes will going to get cancelled in calculation of steady state error, that's why we will take the type. No, the idea is here G1 and G2, if you look at, type remains same, order may be different, correct? So what does it mean? If you go with the type, then we can generalize the steady state error. If you go with the order, we cannot generalize the system because G1, G2 might have the same type but different order. So it is better to take the reference as the type of the system rather than order of the system. Clear? So is it clear to all of you? This is a new point today you have learned, right? So please let me know if you learned this newly today. In the comment section say yes. Why the type is used rather than the order here. Okay. So first one is what? Type 0 system. If you apply step input, then the steady state error will be equal to 1 by 1 plus kp. Clear? Everyone must answer. Yes. Have you understood today that why type is taken rather than the order here? Because the type may be same, order might be different. Correct? That's why. Now 1 by 1 plus kp is the steady state error that we will be getting if you apply step input to the type 0 system. Clear? ECE student here. Right. Very good. So the second is when we apply the ramp input, what is this value and what is this value? I want your side. So it would be like infinity here and it would be like infinity here. Clear? And next type 1 system, this is 0 here and it must be like, because when we apply the ramp only velocity error will exist. So that is velocity coefficient 1 by kv. Of course this would be considered as infinity. Clear? And the third one is it is 0 and 0 it is going to be 1 divided by k. Clear? 1 divided by k. If you can remember this formula, directly you can see the question, look at what is the input you are applying and look at what is the type of the system. If you know these two things, directly you can actually get into. Clear? Directly you can solve the question. That is one easy thing. But as I was saying, see, I am like a, I have topped the gate more than 10 times, 11 times I have topped the exam. My personal experience says that instead of going for kacha-bicha formulas, it is better to believe your basics. The reason is, there is a chance that they may ask the question if the feedback is not having the unity gain. In that case, this is the concept that will help you. Clear? Hope you understood that. Now let's move on to the next concept, that is stability analysis. Good. Slowly we came to the stability. I hope you people are enjoying. Now keep every one of you, whoever are energetic, please let me know in the comment section. Second chapter we have made it. Is it clear to all of you? Have you learnt at least one single new point in the second chapter? I think 2 new points I have explained, right? Okay. So Nataraj is saying yes, yes. Great guys, I am really seeing a lot of energy in you, and still from the starting of the session, I was seeing only 5 to 6 members have left. It's really very great love you are having and great intent to study. Good. Stability analysis. Most important thing in stability analysis is to understand what is the definition of stability. After that, mathematically how we define the, how we will evaluate the stability. Okay? So generally the basic funda of the stability is, if the area under the impulse response of a system is bounded, then the system is considered as a stable system. That means we will take a system, we will apply the bounded input, that is impulse input we will apply. We will apply the impulse input, and when we apply the impulse input, let's say impulse response is, for example, I am saying it is equal to h of t. Assume that impulse response is h of t. Okay. What we do is, we will take the area under this curve, that is from minus infinity to infinity d of t. If this area under the curve is finite, if this value is finite, then I can say this is the bounded output, or I can say the area under the impulse response is bounded. So the system is stable system. Clear? How we need to use the dominant pole concept in solving the problem. So yes, you are asking about how to solve the dominant pole, or you are asking what is the practical significance of dominant pole. Please let me know the question clearly. Right? Yes, yes. Good. Bibo, finite input range. Excellent. Hrithik, please let me know, do you want me to explain about the dominant physical significance of dominant pole concept, or do you want me to explain how to solve the dominant pole question? Please let me know. Yes. So suppose let us say, so there is one particular system. Assume that there is some system here. Its impulse response, look at that, its impulse response h of t is coming like equal to e power minus 2t. Clear? E power minus 2t is the impulse response. Now tell me, for this system, if I integrate the response, or if I find the area under the response, is it finite or infinite? Simple. In solving the question, so that means you want the mathematical application. Yeah, please Hrithik, just hold for 2 minutes, I will explain, don't worry. Right? H of t is equal to e power minus 2t. Right? So now the most important thing is, if you look at the graph of h of t, this goes like this. This is the exponential, exponentially decreasing graph. So that means, what does it mean here? It means that h of t, impulse response, if you see, this is impulse response. But minus infinity to plus infinity integration means what? Area under this graph. Now tell me, area under this graph is finite or bounded or unbounded? You can calculate this area, right? Because it is a decreasing graph, we can calculate the area. So therefore, as the area is bounded here, so I can say, finally, if you take the integration of this value, minus infinity to infinity, h of t dt, right? So this will come finite. So that means it is a stable system, correct? It is a stable system, right? So now I request you to take the Laplace transform of this one. What you will going to get? 1 by s plus 2 you will be getting, correct? E power minus 2t means it is 1 by s plus 2, isn't it? This means if the pole, what is the pole of this one now? The pole is going to be, so look at that, pole is going to be how much here? Pole is s is equal to minus 2, am I right? Pole is equal to s is equal to minus 2, isn't it? Pole is equal to s is equal to minus 2. What does it mean? If the pole is the negative value, that is minus 2 or negative real number, then I am sure that you will going to get an exponentially decaying response in the impulse, and then the area under the impulse response is bounded. That's why we call this as a stable system by using the Bibo principle. Clear? By using the Bibo principle. Now I will explain another way. So this is system 1 you can take. System 2, if you look at, so system 2, h of t, if I say, it might be like e power 2t here. Clear? E power 2t. In this case, what will going to happen? It is exponentially increasing graph here, right? So if you start collecting the area under this graph, so it will become infinite. That's why if you look at the pole of this one, how it looks like 1 divided by s minus 2, if you take Laplace transform of this one. So Laplace transform of this one is going to be 1 by s minus 2. That means a pole is there in the right hand side of s plane. So the impulse response is unbounded. So the system is unstable. Clear? So that means technically we may speak only with respect to the location of the pole in the s plane. But basically, location of the pole in the S-plane inherently explains you about the impulse response or else it will inform you about this integration of the impulse response. Clear? So, in short, what should I say is, of course, it is very difficult to go with each and everything here. So, the very important thing in fact, the first one is, if all the poles of a system, any system, that may be closed loop system or open loop system, if they lie in the left half of S-plane, then the system is stable. Clear? So, if they ask a question like whether the closed loop system is stable or not, then you should look at the closed loop poles. If they ask a question like open loop, then you should look at the open loop poles. If all the poles, not even a single pole should write on the right hand side, all poles must stay in the left hand side of the S-plane, then I can say the closed loop system is stable. Clear? So that means that is one thing. And second is, if one pole lies at origin or complex conjugate poles lies on the imaginary axis, then the system is marginally stable. This is very, very important. Look at that. If one pole, at least one pole lies at the origin or complex conjugate poles on imaginary axis, right? So lies, then this system is marginally stable. Yes, yes, this is correct. What do you mean by that? So let me tell you in a simple way. First case, look at that, all the poles, that is S-plane may be written like this. This is S-plane. If I say clearly, S-plane means, of course, you will be having S-plane here. So this is sigma and this is minus sigma, and as you know that this is j omega and this is minus j omega. All poles might be anywhere in the left hand side. So this is one pole, this is another pole, third pole, pole, like this. If all poles lies in the left hand side of the S-plane, left hand side, then the system is stable. Absolutely it is stable, correct? But what about the situation if the poles lie on the imaginary axis, complex conjugates, right? So now if I say second condition is, right, so again this is a j omega plane, so that is j omega minus j omega here, and let me call this as sigma, and this is going to be minus sigma here. Now can you tell me here, any one of you, what would be the situation for marginally stable system here? Can you guess? Marginally stable system, you may have one pole here at origin, single pole at origin, or else even if you have complex conjugate pole, non-repeated complex conjugate pole. So non-repeated, let me write down non-repeated complex conjugate pole, then the system is marginally stable, And in case, if at all, the poles on the imaginary axis are repeated, right, look at that. If at least one pole lies in the right hand side of the S-plane, this is very, very important. At least one pole lies in the right side of the S-plane, or the poles on the imaginary axis are repeated, then the system is unstable. Clear? Then the system is unstable. Now I will ask a simple question to every one of you. Please let me know. So this is a simple question, I know, that is so anyway, this is for explanation purpose I have given, but in the notes you must have all these 3 points here. Clear? So everyone take your rough paper as well as pen with you and answer the questions whatever I am going to put it now. Everyone must be fast enough to answer the questions. Suppose let us say I have j omega axis like this. Clear? I have j omega axis, so this is j omega minus j omega, and this is sigma here and minus sigma here. So any one of you, Premit, can you tell me here, Premit, Ravi Shankar, you all must tell me. Suppose let us say I have pole here, one pole here and another pole here. It may be written like 2j here and minus 2j here. Clear? Tell me whether this system is marginally stable or unstable. Marginally stable or unstable. Everyone, fatafat, all 42 students should answer this question. So if you are having the poles on the imaginary axis, only imaginary axis, this is a marginally stable system, correct? It's not repeated, it's there on the imaginary axis. Now if I have one more pole like this, yes, because if you are having non-repeated poles on the imaginary axis, then the system is marginally stable system. Clear? Now if I have one pole here in the left hand side of the S-plane, this is considered as the left hand side of the S-plane, and of course this is considered as the right hand side of the S-plane. Now can anybody tell here what is the, if you have even one pole here, now again the whole system is marginally stable system. Why? You have complex conjugate poles. Now I will ask a simple question. Suppose if I say you have two poles at the origin, Then every one of you tell me, if you have two poles at origin, now what will going to happen? What will going to happen? The whole system now, it will become unstable. Why? The pole which is there at the origin or on the imaginary axis, it is repeated, correct? If it is repeated, what I said, so if the poles on the imaginary axis are repeated, the origin is also there on the imaginary axis, repeated, then the system is unstable. That means the addition of the pole or the pole placement as well as the addition of the pole can change the stability of a system. That's why control system is very interesting. I can make a stable system as an unstable system, or I can make unstable system as a stable system only by changing the location of the poles or adding the new poles into the existing system. Clear? So hope you understood this one, right? So interesting. Now tell me, suppose in case there might be a chance that we have like 1 by s. This is marginally stable system. If I want to make this as intentionally unstable, what I will do? I will just multiply with the integrator this one. So this is the exact system and I am cascading with the integrator. When I cascade the integrator to the existing plant, total it will become 1 by s square. Then you will going to get a repeated poles there. That means if we have g of s as 1 by s, gp of s or the plant transfer function as g of s, and if you use the controller as 1 by s, that is integral controller, then integral controller is connected to 1 by s plant. Then what will going to happen? These two, when they cascaded, it will become 1 by s square. Then the poles will be repeated and the closed loop system will become unstable. Clear? That time, if your plant transfer function or the system transfer function is 1 by s, don't use the controller as the integral controller. Don't use integral controller. Use some other controller. Clear? So that's the beauty of this. Ravi Shankar, I think you have enjoyed this, right? So you have enjoyed it. Why we don't use the integral controller here? But anyway, so I moved little bit out of the context. So this is the way how we will be able to say whether the system is stable or unstable just by looking at the pole placement here. Clear? Right. So now moving ahead to the next one, that is, there are several tools to find out, the idea of finding the stability, right? So the best technique in fact, the fundamental technique is RH criteria. I should say that even root locus can also give the stability analysis. Not only root locus, right? So in root locus, the advantage is it will going to give the time domain specifications also, right? So and then stability can also be found by gain margin and phase margin, and stability can also be found by the Bode plot, polar plot, and all these things. Bode plot, polar and Nyquist plot. So the context is, whatever you are going to study from now onwards, more or less the main intention is to find out the stability. Clear? So that's sir waiting for root locus. Okay. I am coming to root locus, right? Sir, it's also improves our knowledge. Good, very much. Thank you very much, Pankaj. You people are really motivating me. Even today I am not feeling so well, but after seeing your energy and your interest, I am also getting boosted. Okay, right. So now moving ahead to the Routh-Harwich criteria, as I was saying. So the consider nth order characteristic equation. First of all, how to construct the Routh table. Suppose if you have a polynomial like this, what we will do? First we will frame the fundamental rows of the Routh array. So starting with the s power n minus 1, and here we will be having s power n minus 2, something like that, and we will go up to s power 0 here. Clear? So when you are writing the data here, first we will write this coefficient a power n and leave this one, go to the next coefficient and write here, and leave the next alternative coefficient and write down this one. Exactly s power n minus 1, we will write the intermediate one. That means when you are writing the s power n minus 1 coefficient, what we will do? We will first take s power n minus 1 coefficient, that is this one, and then leave the next one and go alternatively like this. And then these two rows are called as the fundamental rows of the Routh table, or else these two are called as the fundamental rows. After framing the fundamental rows, then the immediate observation is you have to make B1 here and B2 here. What is the value of B1 here? Simple. B1 could be written as equal to, yes, B1 could be written as this into this minus this into this divided by this, correct? So this value will be equal to how much? A n minus 1 into A n minus 2 minus A n into an minus 3 whole divided by how much you will be having here, b1. So this value should be divided with this. So this is an minus 1. Similarly, b2, if you do it, what is the value of b2 here? So b2 means from here to here you have to take, and this to this, of course, and divided by this one. So therefore, I can write down clearly that it is going to be equal to an minus 1 into an minus 4 minus an into an minus 5, of course, divided by what should be there here. Again, it is going to be an minus 1. Likewise, we will going to continue the same thing. Sir, explanation is secret of our energy. Sir, thank you very much. Thank you very much. Right. So this is the way how we will going to continue the Routh table. Just as I required to explain this, I am explaining, but I feel that every one of you know about the Routh table. Correct? I don't think so. Without any idea about the Routh table, you people might not be sitting in this class. Correct or not? So let me directly go to the conclusions. How do we find the stability here? So the easiest thing is, if at all, look at that, if there is no sign change in the first column of the Routh table, then the closed loop system is stable. Clear? Then the closed loop system is stable. Now I have a second question. If there are sign changes, that means what we do is, for a given characteristic equation, we will try to find out the the Routh table. So it may be like a s power 3 here, s square, s power 1, s power 0, like that we will do. And when we do all the calculations here, what we do is, we will look at the first column of the Routh table. And if there are no sign changes in the first column of the Routh table, then we say that the closed loop system is stable. Now I will ask the reverse way the questions. For example, let us assume that, let me tell you in another way, assume that for a particular case, I framed the Routh table. Example, I am taking an example here. Just look at that. The example is here, as I was saying, maybe like a s power 3, s power 2, s power 1, s power 0, and it is like 3, 4, 5, and here minus 3 and 6 and 7, and here maybe you can take like 2 here, 0, 1, and here 1. That's it. Now tell me whether this system is stable system or unstable system. Every one of you, Narasimha and all, please let me know. Ashok, Narasimha, Ravi, every one of you. So if you look at this one, in the first column of the Routh array, we are not having same sign change is there. Here it is a positive number, here it is a negative number. That means from here to here, one sign change is there. Again from negative to positive, two sign changes are there. Correct? Second sign change. Therefore, we say that this kind of Routh table is unstable. As the two sign changes are there, there is a chance that the two roots will be there in the two roots of the characteristic equation lies in the right hand side of the S plane. Clear? So therefore, we can write down the conclusion like this. If look at that, if there are sign changes in the first column of the Routh table, then the closed loop system is unstable. Of course, the number of sign changes is equal to number of roots of the characteristic equation lies in the right hand side of S plane. Now I have one beautiful question to all of you. Please let me know. Suppose in case when you are writing this way, just revise with me, just think with me, right? So suppose, have you ever got this kind of situation here? We have like 3 here, 4 here, 5. Maybe this term might be 0. Okay, you are getting 0 here, and here you might be having like 4, 6, right? So something like that. Then what we need to do? In case if the first element of any row becomes 0, you must take this as a epsilon, correct? You must take this as a epsilon, or epsilon is considered as a small positive number, very small positive number, and you should continue the algorithm, or you should continue the Routh table, finish the Routh table. That means instead of 0, replace that with the epsilon. This is very, very important, right? So what I will do here now, instead of that, I will going to keep this as a epsilon here, and then continue to make it. So that means 4 times of epsilon here, minus 12 divided by epsilon. Likewise, I will going to continue till the end, right? So then what we will do here, after making the continuation, so once you find the entire Routh table, then at each and every term, I told you that epsilon is a small positive number. Why we will take only positive number? Why not the negative number? Have you ever seen this? Why we will take only small positive number? Why not the negative number? This kind of questions I used to get in the regular classes. Because we don't want intentionally the system to make unstable, correct? We don't want intentionally the system to make unstable. We will take this as a small positive number and we will continue the algorithm. If you are not getting any sign changes, that means the positive number is correct. Correct or not? So that is our guess. If you want to take with the negative, you can go with that, no problem, right? It will turn us, right? Replace with the epsilon, good. So now, after making this, we have to keep limit epsilon tends to 0, means it is a small positive number. Look at that 4 epsilon minus 12 divided by epsilon. So if you take epsilon outside and cancel this, and I am very much sure this value will become how much? This value will become minus infinity here, correct? So that means I am very sure if you substitute epsilon is equal to small positive number, you will be getting minus infinity here, because epsilon you will take outside and cancel. It will become 1 minus 12 by epsilon, correct? So when you substitute epsilon is equal to infinity, overall value will become minus infinity. Clear? So that is how we will try to frame and continue the loop or continue the table by a small positive number called epsilon, in case if we encounter anywhere the first element of a row becomes 0. And that's what I have concluded here. So this conclusion you can keep it in your notebook, which is very, very useful. Clear? So rest of the stability analysis is same. That means after making the epsilon, once you complete the entire route table, then again look at the number of sign changes. If you don't have any sign changes, once again you can tell that the system is closed loop system is stable. Clear? Now there is one beautiful question that was asked to me in IISc Bangalore interview. When I attended IISc Bangalore interview, physics department, I remember that. Okay, they were asking very simple questions at the starting of the interview. Because usually whoever goes for the IISc interview, at starting the questions will be very simple. They will ask that what do you mean by Laplace transform? Then you feel that okay, I know everything. These guys are asking very simple question. You will say that a Laplace transform is this. Then they will ask a very simple question. What do you mean by linear system? Then you will answer that question. Slowly they enhances and they will ask the question. Now let me ask one question to you. RH criteria is used to find the stability of closed loop control system or open loop control system. Every one of you must answer this question. Pankaj, 45 students are there. Anita, Nishant Kumar, Pankaj, Narasimha, Ravi. RH criteria is used to find out the stability of the closed loop system or open loop system. Right? Then we should not answer. Right. Actually, Narasimha, till you stop answering the question, they will keep on asking the question, either in IISc or IIT. Okay. So closed loop, good, very good. Our main intention is to find out the stability of the closed loop system. You are applying the Routh table concept or Routh-Harwich criteria to the characteristic equation, correct? You are taking the characteristic equation and forming the Routh table and analyzing the stability. What does it mean? You are looking for the closed loop system stability, guys, correct? That's simple to understand, isn't it? Now let's move on to the next one, that is all zero row, which is very important and where the students commits the mistake, right? So first of all, why the all zero rows comes into the picture, right? So why all zero rows comes into the picture? So very simple. Any one of you, if in case if your poles are symmetrical on j omega s plane, so select the poles like this is minus sigma and this is minus j omega. In case if your poles are symmetrical, for example, one pole is lying here, one pole is lying here, one pole is lying here, one pole is lying here. This is a symmetrical combo, right? If it is a symmetrical poles are there about the real axis, then you will about the real axis, clear? Then you will going to get all zero rows, clear? All zero rows. Now this system is a stable system or marginally stable system. Marginally stable. This is, we have a very valid point and very interesting point. So please be with me till the end of Routh-Harwich criteria. Everything we do is for closed loop system. Is there anything for open loop control system? So open loop control system stability is easy, right? They will give you a function to you and look at the poles location. Simple. So look at the poles location. If the poles location is left side, then we call the system as stable. Or if at least one pole is there on the right side, then the open loop system is unstable. See, RH criteria can be applied for open loop system also. In open loop, we have a denominator, right? Take the denominator and try to apply RH criteria. Same logic what you have done for the characteristic equation, the same logic you will be applying for there also. Because RH criteria is a mathematical tool. That mathematical tool we can apply for open loop as well as closed loop. But in classical control theory, open loop control system stability is given to you. You require to make the closed loop system to be stable. That's why majority times we will use the RH criteria to find the stability of closed loop control system. Clear? So suppose simple way I will ask a question. I have a glass, okay, or else I have this bottle with me, correct? So in this bottle I can fill with water, I can even fill with the buttermilk also, correct? But most of the times I will use this bottle for water replacement or water filling, correct? Similarly, RH criteria, as majority times we will use that for the mathematical tool to find the closed loop system stability. People say that the closed loop system stability, but that is a mathematical tool and that can be used even for the open loop control system also. Clear? So Narasimha, then it is easy question, right? So Narasimha, is it clear to you? You guys are interacting too much, so that's really great. Okay, very good. Now tell me, this system is stable or unstable? Somebody is saying marginally stable system. Guys, how it is marginally stable system? Anita, look at this one. Nishant, tell me, is it marginally stable or unstable? This is unstable. Why? You should not satisfy only with the condition of having the symmetrical poles. There is one pole which is there in the right hand side, correct? That will make the unstable system, right? So that means many times I have seen the students feel that whenever we are having all zero row, people start thinking that it is a marginally stable system. No, when you have all zero row, it need not necessary that you will be having marginally stable system. You may be having marginally stable system or unstable system, but definitely not the stable system. You will not definitely have the stable system, because this is one case I would like to say, right? So there might be another case, right? So now you see here, if I have the poles like this, now tell me, all zero row will come here or not? All zero row will come here or not? Even one pole present in, yes, right, now clear, sir, very good. Now look at that, this is case 1, right? Here you will going to get all zero row. Definitely you will get all zero row because poles are symmetrical completely, correct? But it is unstable. It is unstable, right? Here case 2, in case 2 also we are having symmetrical poles, right? Symmetrical about the real axis. That's why I told you that symmetrical about the real axis, right? This symmetrical about the real axis. So what does it mean? This is going to be all zero row. Very good, excellent. All zero row will come, but this is a stable system. Clear? This is a stable system. Sorry, this is marginally stable system. Clear? Because one set of complex conjugate poles are there. It's a marginally stable system. Now let me ask a beautiful question. Everybody, you be ready and tell me. Case 3 I will ask. This is really a very interesting ball game, right? Are you guys feeling interested about these things, right? I am really excited, really. Initially I was thinking that how to take 2 hours or 3 hours of class for the control system, but after seeing your response, I am very happy. How much fees I want to pay for the GATE 2025? Jaideep, you can drop your message. Our team will coordinate you, because this is not the right platform and I am not the right person. Okay, right? So now look at that. This is case 2. मैं एक और case बता दूंगा. Like assume that now I have repeated poles here. Then tell me what will happen. First of all, will you get all zero rows or not? Will you get all zero rows or not? Tell me that one first. Yes, here we will be getting all zero row. Definitely we will be getting all zero row. Undoubtedly, we will be getting all zero row. At the same time, you are getting all zero row, but this system is stable or unstable? Stable or unstable? Yes, oh, very nice. You have already made it. Excellent, right? So this is unstable. Excellent. So that means you might have understood that whenever we got all zero row, there are 2 possibilities. 2 possibilities are there for all zero row. Either you will be getting unstable or marginally stable. Either we will be getting unstable or marginally stable. Now think logically and tell me, will you get any chance? Will you get any chance where we will be having symmetrical poles just like that and the system may be stable also? Think logically and look at that. That will be very interesting. Okay, right. So now let me tell you, the descriptive way of this. So the first thing is all zero row is the result of the symmetrical poles here. As I was saying, symmetrical roots of the characteristic equation. Roots of characteristic equation are nothing but the poles of the closed loop system. You must also remember this point. This is very, very important. Roots of characteristic equation, CE stands for characteristic equation, are nothing but poles of closed loop control system. Clear? Closed loop control system. Excellent, right? So now all-zero row, as I was saying, this is fine. And the second thing is, order of the all-zero row is equal to the number of symmetrical poles. Clear? So that means all-zero row, if it is coming in the, suppose let us say, right? So you are having, yes. Next one, I'll tell you. When we have all-zero row, we are going to frame auxiliary equation. This is important. So let me say, suppose s power 4, s power 3 and s power 2, s power 1, something like this it is, we are having s power 5. S power 5 I have something, but look at that, s power 4 is also having, some value here, right? But s power 3 we are having all zeros here. Clear? S power 3 we are having all zeros. So this would be considered as an all zero row here. Correct? Right? So all zero row here. Right? Represent pole. Very good. Right? All zero row. If we get all zero row, what we will do? We will go to the one step ahead of this one, s power 4. Right? So let us assume that in s power 4 we have some data like this. Just assume like this. Clear? Just assume in this way. Maybe you are having like a 4 and 3, 2. So then how we will frame the auxiliary equation now? Now the auxiliary equation is equal to 4 times of s power 4 plus 3 times of s square plus 2. Clear? But where is the all zero row? At s cube. And when we have all zero row, we cannot continue this. This means 4 symmetrical roots. Good. Very good. Very good. Correct. Yes, Pramit. Correct. So you have auxiliary equation order is 4. Right? Now it is not 4 roots are symmetrical. That is the meaning of that. 4 symmetrical root ka baat nahi hai. 4 roots are symmetrical in S plane. Now we have 4 into s power 4 plus 3 into s square plus 2. How do we get the coefficient of the s power 3? Every one of you please message me in the comment section. Great response from your side. Excellent. Right? So if you have 4th order like this, you need the 3rd order. From the 4th order to get the 3rd order, what is the way? What is the mathematical expression or what is the mathematical function? 4th order we need to fill the 3rd order. Then what to do? We have to derivate or differentiate. That means take this auxiliary equation and differentiate this with respect to s. Then you will be getting here 16 into s power 3 plus 6 into s. Correct? And this 16 and 6 we will take here. Now we will write 16 here and 6 here. Continue to work out the same thing. Clear? So we will continue the table. Now I hope you might understood that why we are taking the differentiation here. Our idea is if you take the differentiation, then only power of 4 will become power of 3. I can write the coefficients here. Clear? That is the reason why we will take the differentiation. Clear? That is the reason why we will take the differentiation and continue. Right? So I hope you understood this. And if you want what are the symmetrical poles, what we must do? That symmetrical pole calculation if you want to do, just make auxiliary equation is equal to 0 and find out the roots. That means in the previous case, if you take 4 into s power 4 plus 3 into s square plus 12 is equal to 0. And if you solve this, you will be getting 4 roots which are symmetric. Correct? 4 roots which are symmetric. That means the order of auxiliary equation is equal to the number of symmetrical poles. Order of the auxiliary equation is equal to number of poles. I hope you understood this. Now let me ask most crazy question here. So all of you please see and tell me clearly. You have all zero row plus no sign changes. What does it mean? Don't look at this. Don't look at this. Tell me all zero rows plus no sign changes. इसका मतलब क्या है? What do you mean by this? All zero row plus no sign changes. All zero row indicates the symmetrical poles. No sign changes means there are some poles on the j omega axis, non-repeated poles. So the system is what? Marginally stable system. Clear? So that means all zero row and no sign changes means your poles locations may be like this. Your pole locations, let me tell you, your pole location might be like this. All zero row this one. Here 1 and 1 may be like this. Clear? This is your pole location. Very good, very good, very good, right? So marginally stable. Now algebra row plus sign changes means unstable system. In this case, how it exactly it looks like? 1, 2, 3 like this. This is one combo, or else there might be another combo that it may be having a repeated roots here, here and here also. Clear? There might be a repeated roots, or maybe there is a chance that one more root may be here also, right? That is also possible here. Clear? So that's why we must understand that there are only two possible cases here, either marginally stable or else unstable. So many times what people think is, whenever they get all zero row, they will think that okay, the system is marginally stable system only. No, the system may be marginally stable system, the system may be unstable system. And the difference between these two is, all zero row plus no sign changes will lead to the marginally stable system. All zero row plus sign changes will indicate the unstable system. Clear? Hope you understood this one, right? Clear? For repeated roots, repeated poles, at least another row need to be zero. Good, good. Yes, correct, Pramit. Excellent. Fantastic. Nice. So now coming to the legend of the control system, that is root locus, right? So I think we may take little bit more time today. It may take another 45 minutes of time. Hope you guys can bear me, right? Okay. It seems that you guys are also interested. So let me continue this, right? Okay. Wow. Right. Root locus. Now the first thing is, why the root locus is so popular? In a simple word, I will tell you, the main purpose of the root locus is to see what would be the value of the best gain k such that the roots of the characteristic equation lies in the left hand side of the S-plane. Why? Because if the roots of the characteristic equation lies in the left hand side of the S-plane, then I can say the closed loop system is stable. That means even inherently root locus also will aim to decide the stability of the closed loop system. But God grace, with the root locus we can even find the value of the zeta, we can find the value of omega n, correct? So as we are able to find the zeta value, omega n and all these things, we can even find the time domain specifications from the root locus. Clear? So that's why many people say we are really enjoyed. Very good, very good. Thank you very much. Right? So that's why people say, some people say that yes, root locus can be used for stability analysis. Root locus can also be used for the performance improvement. Performance improvement. Suppose assume that I understood that the percentage of peak overshoot for a system is coming that it is around 70%. Okay, I don't want to see the percentage of overshoot nearly 70%. So I want to reduce the peak overshoot. If I want to reduce the peak overshoot, I need to know how to decrease the damping coefficient, because if you reduce the damping factor, then the percentage of peak overshoot will reduce, correct? So, but how do we reduce the zeta value? Yes, we can reduce the zeta value by changing the controller gain also. This is k. If you change the value of k, then the zeta value can be reduced. If the zeta value is reduced, right, zeta value of the overall closed loop system can be reduced. If the zeta value is reduced, then the percentage of peak overshoot can reduce. If the percentage of peak overshoot is reduced, then I can say the performance of the system is improving. Clear? So tell me, what is the main focus of the root locus now? The main focus is to identify what value of k can bring, k can make the closed loop system as a stable system. That is number one. Number two is what value of k can improve your performance. That means reducing the peak overshoot, reducing the value of settling time, or giving a faster response, reducing the steady state error. All these things we can do with the root locus. That's why root locus is the master of Jack, and in fact it is considered as a hero of the control system. Hope you understood this, and today you might really got what is the logic behind this, right? Now the very first thing what should be known to you when you are having the closed loop system like this, if you find the closed loop system transfer function, this is what you will be having. T of s is equal to k into g of s by 1 plus k into g of s into h of s. Of course, we will be calling the denominator as a characteristic equation. This also you know very well, even better than me also, right? Now, suppose, tell me when this system can be unstable here. Suppose if I say 1 plus k into g of s into h of s. Let's make k is equal to 1 for some time. Assume that k is equal to 1. If k is equal to 1, you will be having something like this, g of s by 1 plus g of s into h of s. Correct? Then the magnitude condition would be written as modulus of g of s into h of s must be equal to 1. Angle condition is at any particular value of s, the phase of the loop gain must be equal to odd multiple of 180 plus or minus 180. Clear? If any value of the s or at any value of s if the magnitude is equal to 1 and the phase of this both are satisfied, then we can say that that point is there on the root locus. Clear? So I hope you might be knowing about the magnitude condition as well as phase condition, but even these are required only for basic understanding, but I will explain you the shortcut how do we find whether a particular value or particular point is there on the root locus or not. Don't worry about that. This is called as a magnitude condition, this is called as the angle condition, and while you are making angle condition, clearly you should look at that the phase must be equal to plus or minus 2q plus 1 into 180 degrees or plus or minus 180 degrees. But in real time systems, in real time classical systems, we will be having only negative phase. Clear? Because number of poles will be either equal to the number of zeros, or many times the number of poles are more than the number of zeros. Then obviously there is a huge probability to get the negative phase. Correct or not? So that's why most of the times it should be equal to minus 180 degrees of odd multiple. Clear? But mathematics will say that angle criteria is this. Now the very first thing, what is the first step in root locus? Any one of you? Anita and Harit Nataraju, Lakshman, right? What is sluggish time? There is no word called sluggish time, to be frank, right? If the settling time is less, then we say that the response is sluggish. Clear? That means if it is taking long time to settle down, then we can say that the response is sluggish. Clear? Right. Any one of you, what is the first step for root locus? The very first step for the root locus is always try to identify your open loop transfer function of the closed loop system, g of s into h of s, which is nothing but the loop gain. You must take this one. Suppose let us assume that it is given like k divided by g of s into h of s all put together. We are having like, otherwise you can even take like this also. Let us take g of s into h of s alone. It would be like 1 by s into s plus 1 into s plus 2, something like this. What would be the first step here in root locus? Identifying the number of poles and number of zeros. Now the total number of poles we call that as a capital P, which is equal to 3 here. Total number of zeros, we don't have any finite zeros, that will be equal to 0. What are the poles here? First pole would be written as 0 and the second pole will be written as -1 and the third pole would be written as a -2. This is the first step. Every time if we have zeros, we have to write zeros, right? So that is simple. Now let me take this as an example so that the things will be very easy and smooth for us. Okay. Now moving ahead, the very first step, as I was saying, we require to identify the segment on the root locus or segment of root locus on the real axis. First step, correct? It is the first step. What should be the first step? As I was saying, number of root locus branches is equal to number of open loop poles. So here when we have number of open loop poles are 3, the total number of root locus branches and the number of open loop poles same. Why? Because the root locus branch always starts from the open loop pole. Root locus branch always starts from the open loop pole. It means that if we have 3 open loop poles, then 3 root locus branches will start. If you have 4 open loop poles, you will have 4 branches that will start from the poles. Clear? Open loop poles, right? So now look at the second important point. Root locus always starts from the open loop finite pole and ends at a 0. Ends at 0, finite 0. This is very, very important. If you don't have finite 0, then it will go to either plus or minus infinity. Clear? Either plus infinity or minus infinity. That means the starting point of the root locus branch is always open loop pole. Ending point of the root locus branch is either finite 0 or infinity. Clear? So now you see here, in this case we don't have any finite 0 and we have 3 root locus branches here. All root locus branches should now terminate only at either plus infinity or minus infinity. You just listen slowly, you will understand that. So the third point is root locus is always symmetrical about the real axis. The great part of this is root locus, if you draw half of the root locus which is above the real axis, below the real axis it will be replica. For example, if I say there is some root locus like this, assume that You know, in this case, when you plot the graph, how it looks like here? Any one of you? So this might be your sigma, and this is minus sigma here. Of course, this is j omega, and this is going to be minus j omega, isn't it? This is the way how your chart looks like here, right? And we have 3 poles here, isn't it? S is equal to 0, 1 pole here. So for time being, let me take S is equal to 0, and S is equal to minus 1 here, and S is equal to minus 2 here. The great part of this is, those students who knows this better way, if you draw above the real axis, the same thing can be replicated even the downside. That means root locus is symmetrical about the real axis. Clear? Now let's try to understand that what you mean by starting from real axis and going away like this. So please see here, all of you. Please see here. So we are having 3 poles, and we will be having 3 different root locus branches. But how they will start? Whether this root locus will start this side or this side. How they will going to start? How to decide that? Any one of you, can you please tell me what is the way to decide this one? Any one of you? What is the way to decide this one? What is the way to decide this one? Any one of you? Simple. We will try to take one point here, this segment, and see right side to this point, how many open loop poles are there? There are no open loop poles, 0, and there are no open loop zeros here, correct? So then when we add p plus g, number of poles plus number of zeros, it is 0. So nothing is there, right? So right side. But when we see here, suppose if you take a point here and look at the right side, of this point. So again, when we take the number of poles, how many open loop poles are there? Only 1 pole is there, that is 1. How many zeros are there here? How many zeros are there? We don't have any zeros here. So therefore, we will be simply putting this as 0 here. Number of poles plus zeros. Now that is equal to 1, correct? That is equal to 1. That means right side to that particular point, if you find the sum of the poles and zeros as a odd number, then that particular point is there on the root locus. This is very simple to know. So if you apply the same logic here, then what you will be getting here? So easy to say. So please see here. All of you try to understand this way. Now the root locus branch or the root locus segments will be what? So if you take any point in between these two, you will be having right side of this particular segment. If you look at, we have only 1 pole here. So that means odd number. Poles plus zeros will be odd number. So this will be there on the root locus. Similarly, if you calculate, even this will also be there in the root locus. This will also be there on the root locus. That is how we will be finding the segments of the root locus on the real axis. Segments of the root locus on the real axis. Remember one important point. Whatever this I have told you just now, the shortcut, that is valid only for the real axis. That is valid only for real axis. Keep that in the mind. And the next one is breakpoints. Now the most important point, what should I say here is, look at the beautiful point. Now we understood that this will start from here and it has to all the way come like this. And this will also all the way it will come like this. When they meet together, there exists a point where they are getting, they are coming and stopping here. So this point is considered as a breakaway point here. Clear? So that means if the root locus exists between two successive poles, there exists a meeting point which is called as a breakaway point. Suppose if the root locus exists between two successive zeros, then in between that what we will going to have? Any one of you, can you tell me? Narasimha, Nishant and all of you. If the root locus lies between two successive poles, there is a chance to have the breakaway point here. Similarly, if the root locus exists between two successive zeros, then there is a chance that we are going to have breakaway point here. In a simple way, so I can say here, so look at that. We are having here, assume that there are 2 poles here. Assume that there is a 1 pole here and 1 pole here and maybe 1 more pole here, 3rd pole here. So the crazy point here is, look at the beautiful point here, that root locus lies here in between this. That means this is coming this way and this is coming all the way like this, right? So if the root locus lies between two successive poles, naturally one will come this way, one will come in this way, both will going to mix together and that will be called as a breakaway point, isn't it? So this will be called as a breakaway point, right? And another way of logic here is, look at that. Here, suppose in this case, assume that we are having one pole here and or else maybe you can say, instead of taking the pole, let me take 0 here, for example. So assume that zeros are there here. We have one 0 here and another 0 here, correct? So if you have two successive zeros here, and I'm very sure that, okay, very sure that if the root locus lies in between these two, assume that root locus lies in between these two, then what is the direction here? Root locus ends only at the 0. So that means this is the direction. So how is it possible? Definitely there must be some point here at which the root locus branches may come into this one, and then after meeting these branches, then only they can terminate at both the sides. They can terminate at both sides, and this is called actually as a breakaway point, correct? But these two root locus branches, here one and here one, they might be coming from the breakaway point of something else. Clear? That is how you should start thinking. So in conclusive statement is, if the root locus lies between two successive poles, that is called as a breakaway point. If the root locus lies between two successive zeros, then that is called as a breakaway point. This is break-in point. I am extremely sorry. This is break-in point. Let me write down. This would be considered here as the break-in point. Break-in point. Excellent. Now how do we find what will happen when the root locus branches are coming all the way like this and meeting together? What will going to happen? Have you ever seen, if you and your friend, both of you are walking too fast and collided exactly with the equal pace, you have collided. At the time of collision, what will be the velocity? Anita, you tell me, at the time of collision, what will be the velocity? Ravi, Narasimha, Nishant and Anita, oh Ravi, round to be. Somebody is asking some question, right? So at the time of collision, perfect collision, what is the velocity? At the time of perfect collision, the velocity will be 0, correct? Both of you will going to stop. So that is the reason why usually at breakaway point, okay, the sensitivity of the root will going to be 0. So we need to take dk by ds is equal to 0. So that means to find out the breakaway point or break-in point, the only simple rule is dk by ds must be equal to 0. So first consider what is the characteristic equation. After that, finding the characteristic equation, then replace for the value of k and then find the dk by ds equal to 0 and solve this, then you will going to get a breakaway point and break-in point here. Sir, how much during this session is? Kandula Sudhir Gupta. If you wait for 5 to 10 minutes, then I will tell you. Okay. So every time the best option is, we are having like, characteristic equation here. So let us say the characteristic equation is 1 plus k into g of s into h of s is equal to 0. Then we will be saying like k is equal to f of s here. So that means rest of everything we will take to that side. After that, we should make dk by ds is equal to 0 and solve this. Then you will have the value of s. How to decide the breakaway point and break-in point? After solving this, if you are getting the value between two successive open loop poles, then you have to check whether that point is there in the root locus branch or not. If it is there, then between two successive roots means it is a break-in point, breakaway point. If it is between two successive zeros means it is break-in point. However, this is the procedure to find out the breakaway point as well as break-in point. Moving ahead to the next one, that is asymptotes. Previously, I told you that suppose in case if the number of poles are more than number of open loop zeros, number of open loop poles are more than number of open loop zeros, right? Then we will be having p minus z roots which cannot terminate at a open loop zeros. They have to go to either plus infinity or minus infinity. But in which direction they have to go, that will be decided by the asymptotes. Clear? Suppose let us say we have number of poles is equal to 3, number of zeros is equal to 0. Number of poles equal to 3, number of zeros is equal to 0. Ravi is asking some question. For closed loop, it is not valid, sir. Which question? Which question you are asking for closed loop? No, actually for root locus, the meaning of the root locus is this. The locus of the roots of characteristic equation. Roots of characteristic equation is definitely for closed loop system only, right? In root locus, you should not get that question also, correct? Because the basic definition is for closed loop system, right? So, P minus Z, yes, Ravi Shankar, no. BAP and B, basically the breakaway point and break-in point are nothing but the locations of closed loop poles. They are not the locations of open loop poles. Because when we are increasing the value of k, roots of the characteristic equation will going to move and they will collide at a point, correct? roots of characteristic equations are moving and meeting means that is the poles of the closed loop system, they are meeting. It means that we are actually doing only for closed loop system. Clear? So we might get angle value. Yes, right? So if P is greater than Z, that means we have to understand that 3 root locus branches will start from open loop poles, but no zeros are there. When you don't have any zeros, then all root locus branches has to go for either plus infinity or minus infinity, right? But in what way they will go? How they will go, right? So that means first of all, number of asymptotes is equal to P minus Z. Clear? P minus Z, right? Why? Because P is greater than Z. Here P is 3 and Z is 0. Then what will be P minus Z? P minus Z, obviously it will be equal to 3, because you require 3 asymptotes to guide 3 root locus branches to plus or minus infinity. Correct? So moving ahead, centroid of the asymptote. The centroid of the asymptote can be calculated as sum of the poles minus sum of the open loop zeros divided by number of poles minus number of zeros. Clear? Number of poles minus number of zeros. Now, why the centroid is required? Yes, of course, you understood that 3 asymptotes are required. But where do we start these 3 asymptotes? Right? So, should I start all these 3 asymptotes from here? Right? Or from here I should start? So, look at that, from where I should start? On the real axis. Should I start from origin, these asymptotes, or should I start at this value, or where should I start? On the real axis. That will be informed by the centroid. So that's why centroid is also very important. Centroid is equal to sigma P. That means sum of all open loop poles minus sum of all open loop zeros divided by P minus Z. Clear? So now moving ahead, yes, we understood that we have to draw the asymptotes from this point. This might be the centroid. Good, excellent. But at what angle I need to draw this one? This might be the centroid. Should I draw at 60 degrees or 180 degrees, 120 degrees? What angle I should draw the asymptotes? That will be informed by angle of asymptotes. Clear? So therefore, the angle of asymptotes could be written here as, okay, angle of asymptotes can be written as, any one of you, can you tell me? Angle of asymptotes usually will write like phi a. This is easy. Phi a is equal to odd multiple of plus or minus 180 here, 2q plus 1 into 180 degrees here, divided by P minus Z here. And you must understand here that Q value may go like from 0, 1, 2, so on up to P minus Z minus 1. Clear? P minus Z minus 1. Simple. Right? Very good. Very good. Nice answers. Excellent, Narsimha. Excellent. All of you are clearly mentioning the answers. Good. Now moving ahead, the imaginary crossover frequency. The next point is whether the root locus may cut the imaginary axis or not. Now you can see there are many chances. In most of the times, root locus branches, they can meet here. Suppose let us say 0 here, we have taken minus 1 and minus 2, something like this. Maybe there exists here that in this example, this will all the way, it will come here, and they will start moving like this and they will cut the imaginary axis. Correct? So if the root locus branch cuts the imaginary axis, what does it mean? Right? So this is the value of K, or exactly at this point. Now it may be having like J2 or J3 or J4 or J5. We don't know whether that is J2 or J3 or J4. But we know that at that particular value, S will become J omega. Why? When the root locus branch cuts the imaginary axis, at this point, the value will be only complex conjugate. Correct? It is simply like complex conjugate with no real part. That is the reason why we will keep like S is equal to J omega. Hope you understood this. So exactly at imaginary crossover frequency or imaginary cut frequency, or else the frequency or the imaginary crossover frequency, we can say S is equal to J omega. Because exactly at cutting point, the root locus cuts the J omega axis with no real value for S. So that's why we will replace, we will get the characteristic equation first and then replace S is equal to J omega simply, and then we will going to convert that into a very simple algebraic equation. Both sides we will going to cover the real part and imaginary part, and finally we will find the value of K at which the root locus cuts the imaginary axis. Correct? And that K is called as critical gain. So please note down this point. Critical gain. that means the gain at which the root locus cuts the imaginary axis, it is called as a critical gain. It is called as a critical gain. Well, I hope you understood this. And most important concept is angle of arrival and angle of departure. Here angle of arrival and angle of departure, these two concepts usually they come here. This is angle of arrival. These two concepts they come when they will come. Narasimha and Ravi Shankar, Lakshman and Anita, tell me when you will be facing the requirement of angle of arrival and angle of departure. You will be facing the requirement of angle of arrival or angle of departure only when we are having the complex poles or complex zeros here. Clear? So suppose, let us say we have complex poles here. What we have discussed earlier, we have discussed clearly that, right? So from the complex pole, every time root locus branch will start coming out of the complex pole. Right now, when it is coming out, whether should it, if I draw a line here, whether it will come like this, or whether it should come like this, or whether it go and come like this, in what way it will come, that will be decided by the angle of departure here. Clear? So that means the angle of departure is the concept that comes into the picture only when we are having complex conjugate poles. Clear? Complex conjugate poles. I hope you understood this one, right? So to find out that angle of departure phi d, suppose if I have like this angle of departure phi d, we must use the formula here, that is 180 degrees minus sigma of theta p minus sigma of theta g. And if it is angle of arrival, just it is 180 degrees plus, everything is same, 180 degrees plus we need to take this one. I hope you might be knowing this, that is sigma theta p is equal to theta p1 theta p2 plus so on. That means all the if you want to find out the angle of departure at this pole, then draw the vectors from all the poles in the system to that particular pole and measure the angle, and those angles contributed by the poles at that particular pole is called as a theta p1 theta p2 respectively, and we'll take the addition of all these things which is called as a sigma theta p here. Clear? So yes, very good Anita, very good, excellent. When we have complex poles and complex zeros, we will use the angle of arrival and angle of departure. Correct? So theta z means what? Theta z means look at the system or look at the plot, draw the vectors to this particular pole from all the zeros, right? And then find the angle contributed by each zero. So therefore, first zero if it contributed theta z1, second zero may contribute theta z2, and we will add all these angles and we will call that as a sigma theta z. And sigma theta p and sigma theta z both should be calculated and subtracted here. So therefore, it should be written as sigma of theta p minus sigma of theta g, and this is considered as the net angle. And if the net angle contribution by the poles and zeros, 180 minus net angle will going to give angle of departure, 180 plus net angle will give the angle of arrival. Clear? So angle of arrival and angle of yes PDF we will going to get, Narasimha, sure you will be getting. So angle of arrival and angle of departure both must be the concept that comes into the picture only in the case of complex poles and complex zeros, right? Apart from this, there are some important concepts like how do we calculate the gain especially, right? So if you have some root locus plot here, so suppose let us say we have root locus plot like this, and they are asking that find the value of k at this point. What should we do? If you want to find out the value of k at any particular point on the root locus, simple, draw the vectors from all poles and zeros and find out the magnitudes. Now you see we have 3 poles here, 1, 2, 3, right? So maybe we require to calculate the gain at this point. Just look at that. We require to find the gain at this point. So what we are doing, we are drawing the lines from each and every value here. So from this pole, this length is how much? 1 unit, correct? And from this pole, what is the length here? Again, this is also 1 unit, right? And from this pole, what is the length? From -4 to -1, this is the length, right? So obviously that is going to be 3 units, correct? So then once you find out the length of the vector from all the poles to that particular point where you require to calculate the gain, happily stay there and multiply all these products. Now 1 into 3, in fact, of course, here we are required to find the value of the gain at this point, correct? We are trying to find the value of gain at this point. So what is the first pole vector value here? P1. What is the value? That means this could be taken as a P1 here. Of course, this would be taken as a, a P2 here, and it must be, 0, right? So from P1 to this particular point, the length is 1 unit. So that is length is 1 unit. And from second pole, that means second pole we are taking here. So from this value to -1, we are having 3 here. Sorry, I'm extremely sorry. So look at that here. From here, -2 to -1, we are having 1 here. So let me write down, this is also 1 here. And from 0 to -1. So that is modulus of 0, 1 here, correct? So this is Z1. How much is the value we are having? From 0 to this particular value, we are having 3, correct? So let me write down, this is equal to 3. So after finding these all the values here, the best way is after finding all these values, then come back here, sum of the, product of the distances from all the poles like this, P1, P2, P3, so on, divided by the product of the distances from all zeros. That would going to give the value of your gain. Simple, very simple. Suppose if you don't have any finite zeros, then we have to take the denominator is equal to 1. Clear? The denominator is equal to 1. Very good, excellent. Kandula Sudhir, very good, very good. Happy to see your responses even after 11:20 also. Really very happy, right? So that's all about the root locus. I hope we have done almost around 50%, 50 to 60% of the control system. But truly speaking, I'm really excited about this session. One thing I should say, I have expected more response, I got more response compared to the expected one, right? I was answering your questions regularly. Meanwhile, we are interacting, we are discussing, right? And some students are even there on the debate side also, right? So this is the reason why the session became little bit lengthy, right? I expected that I can complete the whole session in this time, but as it is getting lengthy, I don't want you to force more than 11:30 AM. So as we have completed up to root locus, the remaining part I will going to take in one more session. Will it be okay, guys? Yeah, we too. Very good. Thank you very much, Narsimha. So 50% of the work we have done it. And as I was saying that you are, interacting more and more, we were lagging a little bit, but I want this discussion. I hope you also want this discussion. So what we will do is the remaining portion, what I have already prepared here, the frequency response and the formulas of, frequency response, Bode plot and everything. I think it would be better if I take in one more session. Otherwise, it may go up to 1 or 2 hours of session now. Deepika, thank you very much. Deepika, thank you very much. Narsimha. Yes, sir. Awesome session. Thank you very much, Ravi. So, but I don't want to lose you guys because you guys are extremely sincere, it looks like, and I wish all the best to every one of you. We will be definitely speaking with the management to have one more session on the control system for the remaining 50%. Meanwhile, you can take this PDF. I will drop this PDF in my Telegram channel also, right? So, at the same time, I will going to keep the PDF even in the description link also. So if you want, immediately you can go and watch all the formulas, and you can keep this particular book as a handbook in your regular notes, or else you can keep this in your bag, okay? Because these notes will be very, very useful. I have put a lot of effort to make this concise discussion, but wonderful to have. Okay, sir, but when we will have the tag to part 2, right? We need today's PDF. Good. So sure, Narsimha, sure, I will give the today's PDF. Right, Telegram channel, right, just give me 1 second. 1 second, guys. See, so many good, diagrams I made, and, very consolidated way I have made actually with a clear plan, right? So you can see like, in fact, Bode plot, Nyquist plot, gain margin, phase margin, the discussion, so many things are there. Polar plot and all these things. If anybody is so serious, you can prepare this by looking at the PPT, PDF also. But as I suggested that we will be definitely having one more session because almost 40% or 50% is left. Okay, I'll inform about the class. This class means a lot to me. Thank you very much, Anita. Very much. Thank you very much. Right. So you all can find, this is the Telegram link here. Right. So the Telegram link is here, and you can just press this in the Telegram so that you will be directed to my channel. And you can find the PDF even in my Telegram channel, or after one day you come back to the session, and in the description box you will be having the PDF. Both you can utilize. And soon I will be speaking with the management to have one more session, and we will really enjoy once again. Okay, frequency response will be completely in another dimension. Those students who attended my session in BYJU'S Exam Prep, they might be knowing that, right? And once again, I am requesting everyone, those students who want eagerly waiting for my lectures, you can go back to the BYJU'S Exam Prep, download the app and look at the lectures. Surely you will feel the another dimension of the control system. Okay, right? So yes, thank you very much. Nice speaking with you, and even I'm very glad to see after 3 hours of section almost, still a lot of people are there in the live. That's really great to see from your side. Right. We get more, but total subject in one session is difficult. Yes, Kandula, that is correct. You really understood the situation. Even today I also understood. But definitely we'll try to make as best as possible. Okay, because I don't want to put it just like this and say that it's completed. I don't do that. Okay, because you are sincere guys, you looks very damn serious for the GATE examination. We'll have one more session and have pleasant discussion about the remaining part of the subject. Meanwhile, if you want the PDF, either you can get it from the Telegram channel or you can get it from the description link. Clear? So once again, thanks to every one of you. Please follow the channel regularly to understand, to know when we are going to have the part 2. Okay, so the timing will be clearly mentioned. So to get the regular update, stay connected to the Telegram channel as well as BYJU'S channel also. Okay, thank you once again. Bye. Take care. Narasimha. Bye. Ravishankar. Bye. Anita. Bye. Kandula. Bye. Natarajan. Bye. Pankaj. Bye. Take care, all of you.